Hello and welcome. Tonight we explore something that exists only in the realm of theoretical possibilities and mathematics, yet shapes how we understand the cosmos and our place within it. We'll journey through the theoretical frameworks that measure the power of civilizations so advanced that their capabilities would appear indistinguishable from magic to us. Consider the vastness of the universe for a moment. Billions upon billions of stars fill the darkness, each potentially orbited by planets where life might emerge and evolve. If intelligence arises on even a fraction of these worlds, and if some of those civilizations survive long enough to develop technology, what becomes possible? How far could advancement truly extend? In 1964, a Soviet astrophysicist named Nikolai Kardashev proposed a revolutionary framework for answering these profound questions. Rather than guessing at alien capabilities, he created a mathematical scale based on energy consumption, a measurable standard for comparing technological advancement across the cosmos. This scale offers us a profound and fascinating lens through which to examine the truly unimaginable. Let's begin this gentle exploration of cosmic power. When we speak of a Type 1 civilization, we describe beings who have mastered their own world completely. These are species that have harnessed all the energy resources available on their home planet. According to Kardashev's original calculations, this represents energy consumption around 4 times 10 to the 19th ergs per second. To put that in perspective, humanity currently stands at approximately 0.72 on the extended scale. We remain far from Type 1 achievement. The path requires not merely incremental progress, but revolutionary breakthroughs in energy generation, storage, and distribution systems spanning entire worlds. Such a civilization would need to capture every available joule from their planetary sphere, converting it into usable power across global infrastructure that would dwarf contemporary civilization by incomprehensible margins. Fusion reactors would cover entire continents, their cooling towers visible from space. Energy transmission beams would move power across oceans instantaneously. Geothermal wells would tap planetary heat. Tidal generators would harvest the moon's gravitational influence. The very atmosphere itself would become a canvas for engineering projects beyond our comprehension. Solar collectors would cover equatorial regions. Every wind pattern would generate power through vast atmospheric turbines. Ocean currents would be trapped and channeled into generating stations. Yet Type 1 represents merely the first rung on an infinite ladder reaching toward the stars beyond. Picture a civilization capable of reaching into the sky and reshaping the weather itself with conscious intention. A Type 1 society would possess the power to manipulate planetary weather systems with precision that would make hurricanes obey commands and reshape the course of storms before they form. The energy released by a single hurricane approaches that of multiple hydrogen bombs detonating simultaneously. Yet, a Type 1 civilization would have such energy in abundance and such control mechanisms that weather would become as manageable as moving water with channels and dams. Control over such phenomena would grant absolute dominion over agriculture, climate, and the distribution of resources across an entire world. Droughts would become historical artifacts as rain could be summoned to parched lands on demand. Heat waves could be dispersed before threatening population centers. Entire regions could be engineered to support whatever climate regime the civilization desired for optimal habitation or resource production. Tropical zones could exist in polar regions. The meteorological sciences would transform from prediction and adaptation to absolute command and design. Weather would become a tool as commonplace to them as the wheel is to contemporary humanity. Beneath the crust of any planet lie tremendous forces waiting to be unleashed or contained according to civilization desires. A Type 1 civilization would have learned to control earthquakes with the same certainty they control weather patterns through vast networks of tectonic stress relievers and stabilizers. The energy released by a magnitude 7 earthquake, compares to thousands of nuclear weapons multiplied many times over. Imagine a civilization capable of releasing such energy in controlled, measured increments, or conversely, of preventing tectonic plates from shifting when such movement threatens cities or farmland or sites of importance. They could induce earthquakes on demand, allowing them to reshape continents through controlled geological engineering on epic scales. Mountains could be flattened or raised through careful manipulation of stress forces beneath the crust. Valleys could be created or filled by triggering and managing tectonic movement. The very skeleton of their world would become malleable under their influence, no longer subject to the arbitrary whims of planetary geology. Volcanoes would no longer pose existential threats, but would instead become power sources and engineering tools, their eruptions channeled and controlled for civilization benefit and energy extraction. The oceans covering a Type 1 world would hold endless energy waiting to be systematically harvested and converted to civilization use. Thermal differences between water layers at various depths, tidal forces from orbital mechanics and planetary rotation, and the sheer mass of moving water all represent potential sources of power awaiting extraction. A civilization commanding complete planetary energy mastery would construct vast ocean-spanning arrays of collectors and energy conversion devices, drawing power from currents and temperature gradients with efficiency approaching theoretical perfection. Desalination on an unprecedented scale would transform salt water to fresh through reverse osmosis and thermal processes powered by abundant energy. Thermal vents at the ocean floor would be tapped and directed toward power generation and resource extraction. Entire underwater cities might be constructed at crushing depths, where a Type 1 civilization's protective technology would make such environments as habitable as any terrestrial location, allowing expansion of population into the ocean depths. The oceans would become not a barrier, but an extension of their civilization, economically and energetically integrated into their planetary infrastructure as fully as land surfaces. Imagine an atmosphere engineered to perfection, with every aspect of air composition, circulation patterns, and chemical balance maintained by conscious design and automated systems. A Type 1 civilization would possess complete atmospheric engineering capabilities unimaginable to contemporary science. They could adjust oxygen levels to enhance cognition or physical performance. They could eliminate pollution as a concept entirely, processing waste gases back into useful compounds through advanced chemistry. Storms would be guided by invisible hand through subtle pressure manipulations. Clouds would be seeded and directed according to agricultural needs. The very taste of the air could be altered if desired, perfumed with beneficial compounds. Atmospheric pressure would be optimized for human comfort or biological perfection in specific regions. What we experience as weather would become instead an orchestrated symphony, each gust and breeze part of a greater planetary system maintained by incomprehensibly advanced technology. The sky itself would become part of their civilization, as much an artifact of their engineering as any building on the surface below. Managing planetary resources at the scale a Type 1 civilization represents an engineering challenge that would dwarf any contemporary infrastructure project by orders of magnitude. Every mineral deposit would be catalogued comprehensively and optimized for extraction according to civilization needs and strategic reserves. Every biological system would be integrated into the resource economy with perfect efficiency, serving civilization while maintaining functional ecosystems. Waste would become a forgotten concept as recycling loops achieved near-perfect closure, with almost all materials cycling continuously. The crust of their world would be tapped systematically for metals and minerals through techniques ranging from traditional mining, modified for scale, to nanotechnology scale extraction at molecular levels. Biological systems would be engineered to produce specific compounds on demand through genetic modification and careful husbandry. Forests wouldn't merely grow wild, but would be cultivated like gardens, each tree positioned for maximum productivity and resource yield. Agriculture would achieve yields that would make present-day farming appear absurdly primitive by comparison, with multiple harvests annually and yields per hectare increased tenfold or more. Every square kilometre of planetary surface would serve the needs of civilization in harmonious integration. A Type 1 civilization would establish permanent presence throughout the space surrounding their world systematically. Orbital stations would ring their planet in vast networks numbering in the thousands or millions, creating industrial zones that couldn't exist under gravity's constraints on planetary surfaces. Solar power collectors positioned in orbit would harvest sunlight continuously and beam it planetside with perfect efficiency through microwave transmission or directed laser beams. Mining operations would expand aggressively to the asteroid belt and beyond, extracting resources from smaller bodies without disturbing planetary ecosystems or causing environmental damage. Space elevators might stretch dramatically from surface to orbital platforms, allowing cheap transport of materials without energy-intensive rocket launches. Massive habitats could be constructed in the vacuum, housing population overflow, or specialized industries requiring extreme conditions impossible on planetary surfaces. The boundary between planet and space would blur as their civilization expanded into the orbital realm, treating near space as a natural extension of their world, deserving of development and exploitation. Asteroids and smaller celestial bodies would become resources to be harvested and repurposed systematically. A Type 1 civilization capable of planetary mastery would extend their mining operations into the asteroid belt, seeking metals and minerals too rare or depleted on their homeworld, or simply exploiting available resources. Robotic probes would survey each asteroid methodically, identifying composition and value with perfect accuracy through spectroscopic analysis. Mining equipment would be deployed to productive asteroids. Automated processes would extract materials continuously, and asteroids would gradually be consumed or reshaped to serve civilization purposes. Some asteroids might be captured into planetary orbit, becoming permanent resource platforms for processing and staging. Others might be drawn into collision trajectories, their contents harvested through impact and careful collection of resulting debris. The solar system would slowly transform under their touch, asteroids vanishing gradually one by one as they were incorporated into expanding civilization infrastructure and resources. The mastery of fusion power would represent one of the earliest achievements on the path to Type 1 civilization and a crucial milestone in energy development. Fusion reactions occurring in stellar cores release energy more efficiently than any other known process in the universe. A Type 1 civilization would have perfected controlled fusion, allowing reactions to occur safely and predictably in reactor chambers distributed worldwide. Cities would be powered by massive fusion plants operating continuously. Vehicles would be propelled by miniaturized fusion engines, enabling global transportation networks. Even individual structures might contain fusion reactors, providing unlimited power to inhabitants. The challenge of containing plasma at temperatures exceeding the sun's surface would have been solved through technologies we can barely imagine or conceive. Magnetic fields of exotic design, crafted from unknown materials, or particle containment through means unknown to contemporary science, would hold stellar fire in absolute check. Fusion would no longer be a distant hope or theoretical possibility, but the everyday foundation of civilization energy infrastructure. As commonplace as combustion engines in contemporary transportation, control over planetary climate at such a comprehensive level would extend beyond simply preventing disasters to actively engineering climate zones optimized for varied purposes across the entire world. A Type 1 civilization might maintain multiple distinct climate regions simultaneously, each serving specific agricultural or biological needs. Tropical zones could be sustained at high latitudes, despite solar geometry. Polar regions could be warmed or cooled to precise specification. Desert regions could be transformed into fertile lands or maintained as controlled environments for specific industrial applications. Seasonal patterns could be smoothed to create perpetual moderate conditions or intensified as needed for specific applications. The entire planetary climate system would become a conscious construction, maintained and adjusted as carefully as a gardener tends a landscape with individual plants. Weather would serve civilization purposes, rather than civilization adapting passively to weather patterns and fluctuations. The continents themselves might be reshaped under the influence of a Type 1 civilization reaching the zenith of their planetary power. Mountains could be leveled gradually to create flat plains suitable for development and expansion. Valleys could be filled completely or deepened further. Coastlines could be extended through land reclamation or altered through careful terraforming. Entire seas might be drained or created where none existed before. Rivers could be redirected to serve agricultural needs and water distribution. The geography of their world would become as malleable as sculpting clay in the hands of artists wielding continental-scale tools. What had existed as natural landscape for billions of years would be intentionally redesigned to serve civilization purposes and aesthetic preferences. The planet would become artifact rather than accident of geological formation. As a Type 1 civilization approaches the limits of what can be achieved through purely planetary means, certain markers would signal their transition toward the next phase of development that would dwarf all previous accomplishment. The population would stabilize at optimal levels, supported by perfect resource management systems that never failed or erred. Scarcity would become a meaningless concept as energy abundance eliminated any possibility of competition for resources across an entire world. Space-based infrastructure would become as routine as planetary development had been, with materials regularly shuttled from orbit to surface and vice versa. Waste would approach zero asymptotically as recycling systems achieved near-perfect efficiency, with almost every atom being reclaimed and redirected toward productive use. Extinction of species would become historical oddity, mentioned only in archives, rather than ongoing catastrophe. The civilization would have achieved stability and sustainability across all domains of existence, with every system in balance. Yet this stability would not represent stagnation, but rather achievement of technical mastery, allowing focus to shift beyond planetary boundaries toward the limitless energy and resources of stellar systems. The real work would be about to begin. When a civilization possesses complete mastery of planetary resources and energy, their thoughts naturally turn outward toward the stars that beckon from across the void. The transition from Type 1 to Type 2 represents the most dramatic change in civilization scope imaginable. A leap from planetary scale to stellar scale that would dwarf all previous achievements. No longer confined to a single world, these beings would begin the laborious process of converting their stellar system into a fully engineered artifact serving every conceivable civilization need. Their sun would become not merely a distant light providing warmth and the energy for planetary life, but instead an energy source to be harvested and controlled with absolute precision through advanced megastructures. Megastructures would be constructed on scales dwarfing anything previously attempted, with materials measured in planetary masses and dimensions measured in millions of kilometers. The entire system would transform into something resembling a vast machine rather than a natural astronomical arrangement of chance and ancient formation. This transition would require breakthroughs in materials science, engineering techniques, and resource management beyond what Type 1 civilization, for all its planetary scale power, would have needed to develop. The concept of surrounding a star with structures to harvest its energy dates back centuries in human thought, proposed by visionaries and scientists who understood the implications of exponential population growth and technological advancement. The idea that a civilization might need to capture stellar energy to sustain continued growth into the future is logical and elegant in its simplicity. One physicist named Dyson proposed that civilizations might construct shells or elaborate swarms around their stars, collecting radiated energy for civilization use across vast populations and expanding territories. Such a structure, called a Dyson sphere, or more realistically a Dyson swarm, would represent the ultimate energy harvesting mechanism possible within a single star system. A thin shell at orbital distances would collect only a fraction of the star's energy output, allowing sunlight to pass through and continue into space. Denser shells at multiple orbital layers could approach collecting and redirecting almost all radiation emitted by the star. The engineering required would be extraordinary beyond conventional understanding, yet theoretically possible for a sufficiently advanced Type II civilization with millions of years to complete the construction project. The concept remains the most imaginative and practical proposal for Type II civilization engineering to date. As a Type I civilization expands into orbital space and begins constructing the first of the true megastructures that would define Type II achievement, they would begin with swarms rather than solid shells, the more practical approach to harvesting stellar energy. These Dyson swarms would consist of millions or billions of individual solar panels, mirrors, and collectors arranged in carefully calculated orbital patterns maintained through algorithm and precision. They would not be connected to each other, but rather maintained in position through gravitational equilibrium with the star and active station-keeping thrusters, ensuring no collisions occurred between neighboring elements. Each collector would be independently powered, operated, and maintained through autonomous systems or remote control. Energy collected would be converted to useful form through advanced semiconductor technology and beamed to inhabitable zones within the expanding structure using directed energy beams. Gradually, over timescales measured in millions of years, the swarm would grow denser as expansion continued. More collectors would be added in ever-increasing numbers. The fraction of star energy captured would increase gradually from small percentages toward 50%, then 70%, then higher still toward the theoretical limit. The swarm would thicken over time into something approximating a sphere, though never solid, always distributed and porous to allow ventilation and heat dissipation. At the heart of Type II civilization power lies the act of stellar energy capture itself, the fundamental operation upon which all Type II achievement depends. Unlike planetary energy, which comes from the planet's internal heat reserves or intercepted solar radiation, Type II civilization would directly harvest the sun's fusion output through megastructures positioned at optimal distances. Energy beamed from stellar surface would be captured by arrays of collectors and converted into electricity, coherent light, or directed energy for transmission. The efficiency would approach perfect conditions as technology eliminated losses through waste heat dissipation into space. All variations in solar output would be automatically compensated through algorithm-controlled collection and storage systems. The civilization would not merely adapt to stellar energy cycles, but would regulate them as needed, storing excess during high output periods and drawing reserves during fluctuations. The sun would effectively become controlled fusion reactors serving civilization needs, rather than the civilization adapting passively to solar temperament. The entire economic system would be powered by this captured starlight, flowing through vast distribution networks spanning entire solar systems. Constructing Dyson swarms and megastructures of the scale required would demand moving matter on unprecedented scales that would appear miraculous to lesser civilizations. Type II civilizations would need to break apart asteroids, moons, and eventually planets themselves to obtain the raw materials necessary for construction of expanding arrays. Entire worlds might be systematically disassembled, their mass converted into collection devices and habitats through careful processing. The materials would be processed into ultra-strong materials through manufacturing techniques achieving perfection not possible in natural conditions. Collectors would be assembled in orbital shipyards positioned at key locations, extensively tested under simulated conditions, and deployed into position through careful orbital mechanics. This process would require not mere centuries, but potentially millions of years of constant effort that would never falter or diminish. Yet for a civilization with unlimited energy from their star and perfect organization through artificial intelligence systems, it would represent inevitable progression rather than impossible dream. The asteroid belt would gradually diminish as its contents were systematically extracted and incorporated into expanding megastructures. The techniques a Type II civilization would employ to disassemble planets while harvesting their material represent a distinct engineering discipline requiring centuries of development and refinement. Rather than crude destruction that would waste valuable material, the process would resemble careful surgery on a cosmic scale, executed with absolute precision. Targeted gravitational manipulation might separate dense layers from lighter components. Focused energy beams would vaporize selected regions for harvesting specific materials. Nanotechnology or similar molecular scale processes might convert solid matter into desired forms at atomic levels, reorganizing atomic structure. The mass would be sorted by composition with automated systems, with different elements directed toward appropriate uses according to building requirements. Iron and nickel would flow towards structural applications requiring strength and durability. Lighter elements would be processed for habitats and living spaces. Every single atom would be accounted for and directed toward optimal use in the expanding civilization infrastructure. Gradually, planets would shrink visibly as their mass transferred to constructing shell infrastructure and expanding arrays. Moons would vanish completely over generations. The solar system's structure would be fundamentally reorganized from natural arrangement into engineered configuration. The materials extracted from planetary disassembly would be transformed into orbital ring structures of breathtaking scale and ambition that would define the physical presence of Type II civilization. These rings would orbit their stars at various distances and configurations optimized for different purposes. Some would serve as habitats, their enormous internal surfaces providing living space for populations numbering in the trillions, if needed, to house expanding civilization. Others would function as processing facilities or manufacturing centers where raw materials were converted into finished goods. Still others would be dedicated entirely to power collection and distribution functions. The rings would rotate at calculated speeds to create artificial gravity where desired, simulating planetary gravity for inhabitants comfortable in such conditions. Each ring might measure thousands or millions of kilometers in circumference, dwarfing planets and small stars. Multiple rings at different orbital distances would form concentric shells, creating a three-dimensional architecture of unimaginable complexity. The system would resemble an incomprehensibly vast machine created by beings of nearly godlike engineering capability. For a Type II civilization capable of stellar engineering, the concept of trade and economic exchange would transform radically from contemporary understanding. Rather than trading goods across continents as humanity does, commerce would occur between orbital structures separated by millions of kilometers and coordinated by artificial intelligence systems. Manufactured goods would be transported through space in vast quantities via spacecraft operating continuously. Resources would flow between mining operations and manufacturing centers according to optimized algorithms. Information would be transmitted at light speed across expanding networks of quantum-entangled communication systems. The economy would achieve a level of integration impossible for planetary civilizations, with all components functioning as a unified system. Supply chains would operate with perfect efficiency, waste eliminated entirely. No delays or lost shipments would occur, thanks to coordinated networks and predictive systems monitoring every transaction. Trade would become so efficient as to be almost invisible, seamlessly integrating the entire system into one interdependent whole. Communication systems spanning entire solar systems would need to operate with precision and reliability impossible in natural conditions without artificial infrastructure. A Type II civilization would develop quantum-entangled communication networks, allowing instantaneous information transfer across stellar distances without relativistic delay, maintaining coherence across the vast spaces separating orbital structures. Alternatively, they might employ laser-based systems of such power and precision that messages could be transmitted between distant structures without loss or significant delay, using frequencies optimized for interstellar transmission. These networks would form the nervous system of their civilization, carrying information across vast distances and allowing coordination between billions of autonomous systems. Computation would occur in centralized hubs positioned at strategic locations, or be distributed across all structures maintaining local processing capability. Commands would flow from coordinating entities based on collected data and analysis. Real-time data would be collected from every structure and analyzed by artificial intelligence systems, detecting anomalies or inefficiencies. The entire solar system would function as an integrated organism, conscious and purposeful in its operations, responding to stimuli intelligently and adjusting behavior based on optimization algorithms. The concept of a Matryoshka brain represents perhaps the most ambitious and profound potential use of stellar megastructure technology yet conceived. Rather than simply harvesting energy for conventional civilization purposes, a Type II civilization might convert their star and surrounding space into massive computational substrate for processing information on apocalyptic scales. The innermost shell would capture stellar energy directly through solar cells or similar technology. Succeeding shells positioned at greater distances would exploit waste heat cascading down from inner layers, converting thermal radiation into additional computational power through thermovoltaic systems. The entire structure would function as a single incomprehensibly vast computer, performing calculations at speeds and scales that would dwarf Earth's most powerful supercomputers by countless orders of magnitude greater than any present comparison. Such a structure might serve as primary habitat for a civilization's uploaded minds, allowing trillions of inhabitants or more to exist in virtual environments of arbitrary scale and complexity created within the computation substrate. The physical universe would become secondary, less important than the computational realities and simulated worlds created within such megaminds. Command over multiple star systems would represent the next phase in Type II civilization development and expansion. As one star's Dyson swarm approached completion and began generating excess energy beyond civilization requirements, the civilization would turn attention to nearby stellar neighbors accessible through space travel. New swarms would be constructed methodically around additional stars following proven designs and techniques. Transportation networks would link the systems, carrying matter and energy and connecting disparate regions into a single economic system. Population would gradually spread across multiple stars, establishing new colonies and habitats. Trade and communication would unite them into a single civilization controlling 10 star systems, then 100, then 1,000 or more. The expansion would be methodical and inevitable, spreading at the speed of spacecraft traveling between systems, limited ultimately by relativistic constraints and the desire to maintain coherent civilization structure. Over millions of years of sustained effort, the entire stellar neighborhood would come under Type II control through systematic expansion. A single civilization spanning dozens of light years would emerge, unified by communication networks and shared culture. Managing populations distributed across multiple star systems would require organizational structures and technologies capable of maintaining coherence across interstellar distances spanning light years. A Type 2 civilization would likely develop sophisticated networks for decision-making and resource allocation, spanning entire regions of space with perfect coordination. Local governments might manage individual star systems, maintaining autonomy in local matters, while coordinated structures oversaw trade and exchange between them at higher organizational levels. Communication delays would be overcome through quantum entanglement or other exotic solutions, preventing lag in transmission. The civilization would function as true hive mind or distributed intelligence, individual components and systems remaining semi-autonomous in local operations, yet integrated into greater whole through unified systems. Conflicts would be resolved through sophisticated arbitration systems. Resources would flow according to optimized algorithms, balancing needs and efficiency. The entire multi-system civilization would operate with machine-like efficiency and coordination. The stars themselves would become subjects of careful management and husbandry by Type 2 civilizations capable of such cosmic engineering. A star's lifetime is finite by necessity, gradually burning through hydrogen fuel before expanding into red giant form and eventually cooling into white dwarf remnant. A Type 2 civilization would develop techniques for extending stellar lifespans far beyond natural limits, harvesting helium-3 or other products of fusion reactions, while stabilizing the star's core and maintaining optimal conditions for energy production. When a star began approaching the end of its natural life, measured in billions of years, the civilization might engage in stellar engineering to rejuvenate it, prolonging its productive years by millions of additional years through careful manipulation. Some stars might be deliberately accelerated or slowed in their evolution to serve civilization needs, creating portfolios of stars at different evolutionary stages. Stellar engineering would represent one of the highest arts and sciences of Type 2 civilization, undertaken with the precision and care humans might give to tending ancient forests or revered monuments, treating each star as a treasure worthy of protection and enhancement, over truly vast timescales measured in millions of years and beyond. A Type 2 civilization would engage in stellar husbandry of such sophistication and complexity that the natural evolution of stars would become secondary to civilization objectives and designs. Young stars in their prime would be cultivated carefully and protected from disruption to maintain their stability. Middle-aged stars would be optimized for maximum energy production through careful tuning of fusion processes. Older stars approaching end of life would be rejuvenated through advanced techniques or allowed to expire naturally based on civilization calculations of long-term resource efficiency and portfolio optimization. New stars might be engineered into existence through unknown processes involving matter compression or stellar nuclear synthesis, or captured from other regions of the galaxy and transported to civilization territory. The entire stellar neighborhood would be transformed into a carefully maintained garden of stars, each positioned and managed to serve civilization purposes according to long-term strategic plans. What had existed as natural astronomical phenomena for billions of years would become aspects of deliberately designed system, maintained with absolute precision across timescales spanning further millions of years into the unimaginable future. Binary star systems offer unique possibilities for Type 2 civilizations seeking to maximize energy extraction. When two stars orbit a common gravitational center, a civilization might engineer both into a coordinated power generation system. Rather than building separate Dyson swarms independently, they could construct interconnected megastructures spanning the gap between stellar bodies, creating unified networks exploiting gravitational dynamics. Energy collected from one star could be transmitted to the other through vast power beams, creating redundancy impossible in single-star systems. Precision positioning at Lagrange points where forces balance would allow collectors to remain stable with minimal energy expenditure. Over time, stellar wind manipulation could bring the two stars closer, maximizing collector density and efficiency beyond what single-star engineering permits. Neutron stars represent extreme celestial laboratories for Type II civilizations, willing to venture into hazardous environments, accessing unimaginable energy densities. These collapsed stellar remnants pack Sun's mass into city-sized spheres, creating gravitational fields so intense that matter behaves according to alien principles. A Type II civilization might extract material from neutron star surfaces through precise gravitational manipulation and exotic matter states. The process requires extracting degenerate nuclear material safely across intense gradients without catastrophic explosion. This exotic material would prove invaluable for constructing megastructures with unprecedented strength, enabling engineering projects beyond conventional stellar material capabilities. The radiation environment surrounding neutron stars offers opportunities for harvesting high-energy particles and converting them into useful energy. Some civilizations might construct specialized power stations in orbit, harvesting rotation energy through mechanisms exploiting relativistic space-time effects near massive rotating bodies. Black holes represent ultimate energy sources for Type II civilizations willing to accept risks of operating near cosmic points of no return. Unlike neutron stars with manageable environments, black holes present fundamental thermodynamic opportunities transcending conventional extraction. Matter spiraling into black holes releases enormous energy heating to incandescent temperatures in surrounding accretion disks. A civilization could position collectors in calculated orbits, capturing energy from infalling material before it crosses the event horizon. Energy extraction efficiency would exceed fusion reactions by orders of magnitude through relativistic conversion. Advanced civilizations might harvest rotational energy through exotic mechanisms, exploiting frame-dragging effects of space-time. Operating near black holes demands unprecedented engineering precision, yet energy rewards justify the risks for sufficiently capable civilizations. The Penrose process represents extracting energy from rotating black holes, captivating Type II civilizations seeking maximum cosmic energy. Within the ergosphere surrounding rotating black holes, physics allows energy extraction through careful interactions with rotation. A civilization might send matter streams at calculated trajectories, allowing the black hole's rotational energy to transfer to incoming material, which would be retrieved. Energy extracted derives from rotational kinetic energy, slowing the black hole's spin. Sufficiently advanced civilizations could systematically reduce rotation rates of black holes throughout their territory, converting spin energy to usable power. Implementing such systems requires engineering precision and relativistic physics understanding that would seem godlike. Penrose process harvesting would make black hole engineering a highest priority for advanced civilizations. Hawking radiation represents quantum effects by which black holes slowly evaporate and release stored mass energy, presenting mechanisms for energy harvesting. When black holes emit Hawking radiation, they convert mass into pure energy radiating as particles. Civilizations might capture and redirect this radiation, harvesting energy rather than allowing dissipation. Power output increases dramatically as black holes evaporate and grow hotter, meaning ancient ones yield meager power while those nearing end release enormous bursts. Type II or Type III civilizations might deliberately manipulate evaporation rates through positioned particle streams and energy fields, controlling Hawking radiation emission and harvesting maximum energy. Some civilizations might maintain black hole farms with countless black holes of varying ages in carefully managed decay, ensuring constant production as older ones evaporate and newer ones replace them. Accretion disks surrounding black holes represent energetically violent universe regions where matter reaches millions of degrees and releases staggering energy through radiation and particles. A Type 2 civilization might position collection systems in accretion disk regions, extracting energy from infalling material before event horizons. Collectors would need withstanding intense radiation, extreme magnetic environments, and relativistic particle streams. For civilizations with exotic matter and theoretical limit materials science, capturing accretion disk energy represents efficient continuous power. A stellar mass black hole accretion disk generates energy represents efficient continuous power. A stellar mass black hole accretion disk generates energy equivalent to millions of suns, making even partial collection a tremendous prize. Civilizations might construct orbiting stations surviving these extreme environments, extracting energy through particle capture, radiation absorption, and magnetic field use. Technical challenges are immense, but rewards justify engineering efforts for advanced species. Type 2 civilization power limits represent theoretical ceilings requiring transcendence of stellar engineering constraints toward galactic-scale operations. Peak efficiency. Type 2 civilizations harness multiple black hole rotation, capture accretion disk radiation, harvest Penrose process energy, and cover star systems in massive Dyson swarms. Total available energy approaches theoretical limits from thermodynamics and relativity, constrained by solar system mass and operational hazard tolerance. Continued growth requires discovering new stellar systems or breakthrough technologies, accessing more powerful energy. Type 2 to Type 3 transition shifts focus from local stellar energy maximization towards systematic galactic expansion and incorporating additional star systems. At development peak, Type 2 civilizations face inflection points, having maximized single-system achievement, confronting monumental challenges crossing light years to colonize neighboring stars. Galactic expansion represents frontiers for Type 2 civilizations exhausting home star resources and achieving interstellar colonization sophistication. Crossing light-year distances demands spacecraft maintaining near-light velocities or discovering faster-than-light mechanisms despite relativity. Initial expansion focuses on nearest stellar neighbors, with colonization waves spreading across galactic disks. Each star system becomes engineered Dyson swarms, adding energy to civilization budgets. Over millions of years, single systems grow encompassing hundreds, then thousands of scattered stars. Civilizations develop communication networks maintaining coherence across vast distances despite light speed delays. Expansion becomes methodical, driven by exponential growth and advancement, converting galaxies from independent systems into integrated megastructure networks, serving unified civilizations. Type 3 civilizations represent those completing galactic engineering, incorporating vast star numbers and controlling entire galaxy energy output. Such beings operate at scales where individual systems become components like atoms in molecules. Type 3 civilizations possess energy resources 10 billion times greater than Type 2, granting godlike capabilities to lesser species. They manipulate stellar formations across light years, rearrange spiral arm architecture, engineer impossible solutions. Internal organization reflects enormous distances and light speed delays. Autonomous artificial intelligences handle local decisions coordinating with regional systems while maintaining larger strategic goals. Energy resources and technological sophistication allow maintaining effective coordination and unified purpose across entire galactic systems. Colonizing star clusters represents one of the early expansion strategies available to Type 3 civilizations, seeking to consolidate their power base and extend their control across greater distances. Star clusters, whether globular clusters containing millions of stars or open clusters with smaller stellar populations, offer opportunities for rapid expansion and consolidated control over large star populations within relatively compact regions. A Type 3 civilization might systematically engineer every star in a cluster into a megastructure array, converting the entire cluster from a natural astronomical feature into an integrated artificial system. The relatively close proximity of stars within clusters, compared to the galactic average, would allow for more efficient energy transmission and material exchange between systems. Communication lag would remain an issue across the cluster, but would be significantly reduced compared to attempting to operate across the vast spaces separating individual stars scattered across the galactic disk. Some clusters might be reserved for raw resource extraction and manufacturing, their stellar material systematically harvested to construct megastructures and export materials to other regions of space. Other clusters might be optimized for habitation and civilization expansion, their stars engineered to provide optimal conditions for large populations. The most valuable clusters would likely receive the greatest engineering attention, eventually becoming among the densest nodes of civilization infrastructure within the galaxy. Von Neumann probe networks represent perhaps the most elegant and efficient mechanism for a civilization to expand across galactic distances without requiring massive energy expenditures for individual spacecraft or achieving faster-than-light travel capabilities. Self-replicating probes, launched from a civilization's home region, would explore and colonize new star systems through exponential replication, with each probe landing on available asteroids or planets and creating copies of itself using local material and energy resources. The exponential growth rate would allow a single initial probe to spawn trillions of descendants across millions of years, gradually filling the galaxy with probes that would systematically convert each star system they encountered into civilization infrastructure. The probes could operate with minimal direct oversight from the civilization's central authorities, making autonomous decisions about which systems to colonize and how to optimize resource extraction. Over time, the probes would form networks of communication and resource sharing, creating de facto civilization structure without requiring active direction from a central authority. For a sufficiently advanced civilization, willing to invest centuries or millennia in the initial deployment of the probe network, this mechanism would eventually result in galactic conquest, requiring surprisingly little ongoing energy expenditure after the initial investment. The self-replication mechanism would provide redundancy and insurance against catastrophic failures, as the loss of any individual probe or even entire star systems would be insignificant to the overall expansion and conquest process. Self-replicating exploration mechanisms would operate according to principles of exponential growth and algorithmic optimization that would make them extraordinarily effective at expanding civilization influence across vast regions of space. Each probe would be equipped with sophisticated artificial intelligence capable of making complex decisions about resource allocation, replication schedules, and expansion strategies based on local conditions and higher-level civilization objectives transmitted through long-range communication networks. When a probe arrived at a star system, it would assess the system's resources, identify the most efficient location for establishing a replication facility, and begin manufacturing copies of itself using mined and processed local material. The time required to manufacture a copy would typically span years or decades, with the exact timeline depending on local resources and the complexity of the probe design. Once replication completed, descendant probes would launch toward promising nearby star systems, while the original probe remained to monitor the system and extract energy resources for civilization use. Over millions of years, this process would gradually spread probes throughout the galaxy in wave-like expansion patterns, with different probes achieving different replication rates based on local conditions and resource availability. The cumulative effect would be expansion and colonization of essentially the entire galaxy within timescales that represented only a tiny fraction of cosmic history. Galactic communication lag presents one of the most fundamental challenges facing Type 3 civilizations, attempting to maintain coherence and unified purpose across galactic distances spanning tens of thousands of light-years. Any signal transmitted across the galaxy would require years, decades, centuries or even longer to reach its destination, during which the sender would lack any feedback about whether their message was received or acted upon. This speed of light limitation would make real-time coordination impossible, forcing Type 3 civilizations to develop sophisticated strategies for maintaining loose central oversight, while allowing individual systems and regions to operate with substantial autonomy. Higher-level strategic objectives would be transmitted once and expected to propagate throughout civilization networks gradually, with local systems implementing broad directives while retaining freedom to adapt them to local conditions. Redundant communication networks spanning multiple routes would ensure that messages had multiple pathways to reach their destinations, despite the vast distances and communication delays involved. Some civilizations might develop quantum-entangled communication systems that would allow instantaneous information transfer despite relativistic constraints, granting them significant advantages in coordination and response capability compared to civilizations limited to light-speed communication. Relay station networks would be established throughout galactic space to facilitate efficient information transfer and energy transmission across vast distances. These stations, positioned at strategic locations throughout the galaxy, would serve as communication hubs and power distribution centers, receiving signals and energy from multiple directions and retransmitting them toward their ultimate destinations. A sophisticated relay network spanning the entire galaxy would allow any location to communicate with any other location through chains of relay stations, dramatically reducing effective communication time through optimized routing. The relay stations would be automated, operated by artificial intelligence systems capable of making routing decisions and maintaining infrastructure autonomously. Energy transmission through relay networks would allow power generated from distant stars to be redistributed throughout the galactic civilization as needed, creating a distributed power grid spanning hundreds of thousands of light-years. The spacing and strategic placement of relay stations would be optimized through computational analysis, ensuring maximum efficiency and redundancy to prevent catastrophic failures from disrupting civilization-wide communication and energy distribution. Over time, relay networks would become increasingly sophisticated and interconnected, eventually creating unified infrastructure spanning the entire galaxy. Wormhole construction theories represent perhaps the most speculative and exotic mechanism for bridging vast distances and overcoming the speed of light limitations that would otherwise constrain Type 3 civilization expansion and coordination. Theoretical physics suggests that solutions to Einstein's field equations might allow for stable wormholes, tunnels through space-time connecting distant regions separated by enormous distances through normal space. If such structures could be constructed, a sufficiently advanced Type 3 civilization might deliberately create wormholes linking distant star systems, effectively creating shortcuts through space-time that would reduce travel time from years or centuries to days or weeks. The energy requirements for creating and stabilizing wormholes would likely be astronomical, possibly requiring the output of multiple stars or more. But for a Type 3 civilization with access to galactic-scale energy resources, the engineering effort might be justified if it enabled sufficient increase in coordination and expansion efficiency. Natural wormholes, if they existed, might be discovered through astronomical surveys and captured or stabilized for civilization use, immediately granting access to new regions of space without requiring time-consuming expansion efforts. The construction and maintenance of wormholes might become one of the defining engineering projects of advanced Type 3 civilizations, with networks of stable wormholes gradually being constructed throughout galactic space to create an interconnected web of rapid transit corridors. Faster-than-light travel remains one of the most fundamental barriers to galactic-scale civilization development, constrained by relativistic physics and the cosmic speed limit imposed by the structure of space-time itself. Despite intensive research by theoretical physicists, no confirmed mechanism for exceeding light speed has been discovered, and many believe the constraint is absolute and unbreakable. Yet sufficiently advanced Type 3 civilizations might discover loopholes in relativistic constraints through mechanisms not yet understood by contemporary physics. Some theoretical frameworks suggest that manipulation of exotic matter with negative energy density might allow for warping of space-time in ways that would permit faster-than-light travel without violating relativistic principles within the locally warped space-time. Other theories propose that traversing multiple dimensions or leveraging quantum effects at scales where space-time becomes discrete might provide methods to circumvent speed-of-light limitations. A Type 3 civilization willing to invest centuries of research and staggering energy resources into pursuing faster-than-light travel might eventually achieve breakthrough discoveries that would revolutionize their civilization's expansion capability and coordination potential. Even without true faster-than-light travel, spacecraft capable of maintaining near-light velocities indefinitely would eventually allow crossing galactic distances in timescales measured in thousands or tens of thousands of years rather than millions, substantially accelerating expansion timelines. Alcubierre drive concepts, based on theoretical solutions to Einstein's general relativity equations, suggest mechanisms by which spacetime itself might be warped to enable faster-than-light travel for objects contained within a bubble of normal spacetime. The proposed mechanism would involve contracting spacetime in front of a spacecraft and expanding it behind, effectively creating a wave of spacetime distortion that would carry the ship forward at effective velocities exceeding light speed. The exotic matter requirements for creating and maintaining such a warp bubble would be staggering, potentially requiring quantities of negative energy material equal to planetary masses or greater. Despite the enormous technical challenges, a Type 3 civilization with sufficient energy resources and understanding of exotic matter might eventually develop functional warp drive systems capable of transporting vessels across the galaxy in timeframes that would revolutionize exploration and communication. Fleets of warp-capable vessels could spread throughout galactic space far more rapidly than conventional spacecraft, establishing new colonies and connecting civilization infrastructure with unprecedented speed. The discovery or construction of functional warp drives would likely mark a major transition point in Type 3 civilization development, unlocking possibilities for rapid expansion and coordinated action that would previously have been impossible. Spacetime manipulation at the scales achievable by Type 3 civilizations would extend far beyond simple warping for faster-than-light travel, to include wholesale restructuring of the fabric of reality itself in localized regions. A sufficiently advanced civilization might deliberately create artificial spacetime structures or geometries optimized for specific purposes, whether enabling faster communication, enabling massive computational substrate, or allowing for engineering projects impossible in unmodified spacetime. The creation of closed time-like curves through spacetime manipulation might enable limited time travel, though the practical and theoretical consequences of such engineering would demand extraordinary caution and sophistication. Artificial wormholes connecting distant regions, rotating cylinders creating artificial gravity and time-like effects, and exotic spacetime geometries might all be constructed by Type 3 civilizations willing to invest the enormous energy and engineering effort required. The very concept of manipulating spacetime structure would place such civilizations into a category fundamentally distinct from all lesser civilizations, operating with godlike powers over the structure of reality itself in their territories. Galactic core engineering represents one of the most ambitious and dangerous projects a Type 3 civilization might undertake, involving direct manipulation of the supermassive black hole and surrounding massive star populations at the center of the galaxy. The galactic core contains billions of stars and a supermassive black hole millions of times the Sun's mass, creating an environment of such density and energy output that it represents one of the most extreme regions known to exist. A Type 3 civilization might deliberately engineer the galactic core region, converting the massive stellar population into megastructures and harnessing the black hole's energy through sophisticated mechanisms. The engineering challenges would be extraordinary, requiring coordination across billions of individual stars and management of gravitational dynamics on scales difficult even for a Type 3 civilization to fully control. Yet the potential energy and resource yields would make the effort worthwhile, as the galactic core represents an enormous concentration of stellar material and energy generation potential concentrated within a relatively compact region of space. Over millions of years, systematic engineering of the galactic core could transform it from a natural astronomical feature into an artificial system optimized for civilization purposes. Supermassive black hole utilization represents one of the ultimate energy harvesting mechanisms available to Type 3 civilizations willing to engage in the most extreme and exotic engineering. The supermassive black holes at the centers of galaxies contain millions or billions of solar masses and are surrounded by accretion disks of infalling stellar material generating more energy than entire galaxies of normal stars. A Type 3 civilization might position harvesting systems in the accretion disk regions, extracting energy from infalling material before it crossed the event horizon. The Penrose process or similar mechanisms might allow extraction of rotational energy from the black hole itself, gradually spinning it down while converting its rotational energy into usable power. Some advanced civilizations might even construct megastructures at scales approaching the black hole's event horizon, deliberately utilizing the intense gravitational and energy environment to enable engineering projects impossible elsewhere. The extreme hazards of operating so close to supermassive black holes would demand technological capabilities at the very limit of Type 3 civilization potential, yet the energy rewards would justify the extraordinary risks. Star formation control would become a key aspect of Type 3 civilization management of their galactic territory, allowing active direction of stellar evolution and creation of new stars optimized for civilization purposes. Rather than allowing stars to form randomly through gravitational collapse of gas clouds, a Type 3 civilization might deliberately engineer stellar formation in nebulae and interstellar clouds, creating stars with optimal properties for energy harvesting, habitation, or other specific civilization objectives. The ability to create new stars would effectively grant immortality to civilization infrastructure dependent on stellar energy, as aging stars could be replaced by newly formed younger ones as their fuel depleted. Some civilizations might deliberately create binary or multiple star systems optimized for maximum energy output or infrastructure development. The engineering techniques required for controlled star creation would represent some of the most sophisticated astronomical knowledge and capability achievable, placing such civilizations among the most advanced Type 3 entities conceivable. Nebula sculpting would allow Type 3 civilizations to reshape vast clouds of gas and dust distributed across light years of space, reorganizing the raw material of star formation into optimized configurations. Rather than allowing nebulae to evolve randomly, a sufficiently advanced civilization might deliberately shepherd gravitational collapse and star formation within nebulae, creating desired numbers and types of stars distributed according to civilization strategic planning. The material of nebulae could be mined for rare elements or redirected to locations where it would be incorporated into megastructures or new star formation projects. Over millions of years, systematic sculpting of galactic nebulae would gradually transform the entire galaxy from a collection of randomly distributed gas clouds into an organized system of engineered structures, new stars, and organized material distribution optimized for civilization purposes. The sheer scale of such projects would be almost incomprehensible to lesser civilizations, yet Type 3 civilizations with access to galactic-scale energy and billions of years for implementation would make such work routine. Spiral arm modification represents perhaps the most dramatic and visible expression of Type 3 civilization engineering ambitions, involving manipulation of the large-scale structure of the galaxy itself. The spiral arms of galaxies are not rigid structures, but rather density waves propagating through the galactic disk, regions where stellar populations and gas clouds are compressed into higher density than the galactic average. A Type 3 civilization might deliberately modify the propagation and characteristics of spiral arms, transforming them into optimized structures for civilization purposes. Civilizations might create new spiral arms, enhance existing ones, or even eliminate spiral arm structures entirely, transforming the galaxy's appearance from a classical spiral into custom geometries optimized for civilization infrastructure distribution. The engineering mechanisms required would involve subtle manipulation of gravitational fields and stellar dynamics across hundreds of light years, demanding computational and engineering sophistication beyond contemporary comprehension. The visible results would represent the signature of Type 3 civilization activity, transforming the galaxy's appearance in ways that could potentially be observed by distant observers. Galactic rotation management would become a tool for Type 3 civilizations seeking to optimize the orbital dynamics and energy distribution within their territory. Rather than allowing the galaxy to spin according to its natural angular momentum and gravitational dynamics, a sufficiently advanced civilization might deliberately alter rotational rates or introduce artificial forces that would reshape how stellar populations orbited the galactic center. Such manipulation might be used to prevent dangerous stellar collisions, optimize orbital periods for specific civilization objectives, or generate energy through rotational dynamics. The engineering challenges would involve manipulating gravitational fields across dimensions of light years and managing the chaotic dynamics inherent in systems of billions of bodies. Yet for a Type 3 civilization with sufficient energy resources and computational sophistication, such management would become feasible. The resulting galactic rotation would be an artifact of civilization engineering rather than natural gravitational dynamics, representing deliberate restructuring of fundamental galactic properties. Dark matter interaction represents one of the most speculative but potentially revolutionary capabilities of Type 3 civilizations, involving manipulation of the mysterious dark matter that constitutes most of the galaxy's mass. Dark matter, invisible and known primarily through gravitational effects, comprises approximately 5/6 of all matter in galaxies and determines much of their large-scale dynamics. A sufficiently advanced Type 3 civilization might discover mechanisms for detecting, manipulating, or harnessing dark matter, immediately granting access to energy and mass resources dwarfing those of normal matter. If dark matter could be converted to conventional matter or energy through mechanisms unknown to contemporary physics, it would provide Type 3 civilizations with access to energy resources millions or billions of times greater than those available from stellar matter alone. Some advanced civilizations might construct dark matter harvesters or collectors, systematically extracting dark matter from galactic regions and converting it to useful forms. The discovery of functional dark matter manipulation technologies would represent perhaps the greatest leap in Type 3 civilization capabilities, potentially elevating them toward Type 4 status through access to previously inaccessible energy sources. Galactic halo manipulation would allow Type 3 civilizations to reshape the outer regions of their galaxy, the diffuse halo regions extending hundreds of thousands of light years from the galactic center and containing ancient globular clusters, sparse stars, and dark matter. Rather than allowing the halo to remain largely unengineered, a Type 3 civilization might systematically process halo regions, extracting useful material and reorganizing stellar populations. The sparse stellar distribution of halo regions would make systematic engineering more challenging than within the denser galactic disk, yet the enormous volume involved would contain tremendous total resources. Over millions of years, halo engineering could systematically extract rare elements, optimize stellar populations for civilization purposes, and incorporate halo resources into civilization infrastructure. The outer edges of the galaxy might be shaped into organized structures or left as organized harvesting regions, transformed from natural features into artifacts of civilization engineering. Intergalactic bridge building represents perhaps the most ambitious engineering project imaginable for Type 3 civilizations, involving construction of physical or informational connections across the vast distances separating galaxies. The nearest large galaxy to the Milky Way, Andromeda, lies more than 2 million light-years distant. A Type 3 civilization might deliberately construct wormholes, deploy relay stations, or establish other infrastructure linking distant galaxies into a coordinated network. The energy requirements for such projects would be staggering, potentially requiring the output of entire galaxies or more. Yet a sufficiently advanced Type 3 or early Type 4 civilization might view galactic distances as merely one more engineering challenge to be overcome through determined effort over vast timescales. The construction of intergalactic bridges would effectively merge multiple galaxies into a single civilization system, allowing resource exchange and coordination across cosmological distances. The capability for intergalactic expansion would mark the transition from a Type 3 civilization controlling a single galaxy toward emergence of Type 3 to IV civilizations operating on universal scales. Galaxy collision engineering would allow Type 3 civilizations to deliberately manipulate the trajectories and fates of galaxies, potentially harvesting resources from nearby galaxies or merging multiple galaxies into unified systems. Galaxies naturally collide and merge on cosmological timescales, with our own Milky Way destined to merge with Andromeda in several billion years. A Type 3 civilization might deliberately accelerate such collisions, controlling the trajectories and angles to optimize resource harvesting and civilization growth. The engineering challenges would involve moving entire galaxies, a feat requiring energy outputs on scales that would be difficult even for a Type 3 civilization. Yet the potential benefits in terms of resource access and civilization expansion would justify the effort. Some civilizations might deliberately engineer galaxy collisions in hostile regions to eliminate competing civilizations, while others might coordinate mergers to combine their resources and capabilities into larger unified systems. Cosmic web navigation represents the challenge of operating within and traversing the large-scale structure of the universe, the filamentary networks of galaxy clusters and superclusters connected by sheets and filaments of matter separated by enormous voids. A Type 3 civilization controlling a single galaxy would eventually develop capabilities to navigate and potentially reshape the cosmic web structure itself, connecting distant galaxy clusters and manipulating the large-scale distribution of matter. The cosmic web structure would represent the ultimate canvas for civilization engineering ambitions, offering opportunities to reshape the universe's structure on scales that would be incomprehensible to lesser civilizations. Civilizations might construct artificial structures linking galaxy clusters, harvest matter from cosmic voids to support expansion, or reshape the filamentary structures of the cosmic web into optimized configurations. The coordination and energy requirements would be staggering, yet over billions of years, such projects would become routine for Type 3 or Type 4 civilizations. Type 3 civilization markers would include observable signatures that advanced astronomers might potentially detect, evidence of galactic-scale engineering projects visible across vast distances, dimming of stars suggestive of Dyson swarms, unusual radiation patterns from black hole manipulation, warping or distortion of galactic structure inconsistent with natural evolution, and other anomalies would potentially indicate Type 3 civilization presence. Some researchers have speculated about searching for such markers in astronomical data, looking for evidence of galactic-scale engineering among distant galaxies. The detection of a confirmed Type 3 civilization would represent the most profound discovery in human history, immediate evidence that intelligence could survive and advance far beyond contemporary human levels. The technological capabilities represented would be so far beyond human comprehension that communication and mutual understanding might be impossible, despite both being technological civilizations. The mere existence of observable Type 3 civilizations would confirm that the development pathway from human-level technology to godlike capabilities was achievable, providing hope that human civilization might eventually develop similar capabilities given sufficient time and advancement. Observable universe signatures of Type 3 and Type 4 civilizations would extend beyond individual galaxies to potentially include modifications of large-scale cosmic structure, dimming of entire galaxy clusters, and radiation patterns inconsistent with natural cosmological processes. A sufficiently advanced Type 4 civilization might be visible to outside observers through evidence of massive stellar engineering, galaxy-scale projects, or even larger cosmic engineering. Some theoretical frameworks suggest that sufficiently advanced civilizations might deliberately create signals or display their existence to others, though the motivation for doing so and the methods employed remain speculative. The universe might be filled with signatures of advanced civilizations operating at scales we currently lack the sophistication to recognize or interpret. The absence of detected artificial signals, despite careful searching, might simply reflect the difficulty of detecting such subtle signatures across cosmic distances or our lack of knowledge about what to search for. The transition to universal scale represents the conceptual leap from Type 3 civilizations controlling individual galaxies toward Type 4 civilizations beginning to exert influence across the observable universe on scales approaching the entire cosmic structure. A Type 4 civilization would eventually achieve the technological sophistication necessary to manipulate the fundamental constants of physics, reshape space-time geometry on cosmic scales, and potentially create or destroy universes through mechanisms unknown to contemporary physics. The energy resources at Type 4 disposal would approach the total energy content of the observable universe itself, granting essentially unlimited capabilities for any project undertaken. Such civilizations might deliberately restructure the universe's fundamental properties, creating artificial universes optimized for specific purposes, harvesting dark energy to power civilization infrastructure, or even achieving forms of existence completely divorced from ordinary matter and energy as contemporary humans understand it. The very concept of Type 4 civilizations ventures into realms where the distinction between advanced technology and magic becomes meaningless, where capabilities would be indistinguishable from omnipotence as conceptualized in spiritual and religious frameworks. The possibility of Type 4 civilizations existing represents the ultimate frontier of speculation about advanced intelligence, a realm where the laws of physics themselves become subject to deliberate manipulation and modification by sufficiently advanced minds and machines. Type 4 civilizations would stand at the threshold where the distinction between technology and fundamental reality becomes indistinguishable. Such beings would possess the ability to manipulate the very fabric of the universe, to reshape dimensions and bend the laws of physics themselves according to their designs. A Type 4 civilization would harness the energy of the entire observable universe, commanding power outputs approaching 10 to the 44th ergs per second. With such energy resources, they could undertake projects of breathtaking scale. They might move galaxies as lesser beings move planets. They could terraform entire galaxy clusters with the ease that humans modify a garden. For a Type 4 civilization, the universe would become clay in their hands, malleable and responsive to their will. They would possess computational capabilities allowing them to model and predict events across cosmological distances. Time itself might bend to their engineering, with past and future becoming navigable territories rather than fixed immutable dimensions. Galaxy cluster management would represent one of the foundational engineering challenges for an emerging Type 4 civilization seeking to consolidate power across ever vaster regions of space. Galaxy clusters contain hundreds or thousands of individual galaxies, each containing hundreds of billions of stars. A Type 4 civilization might systematically convert each galaxy within a cluster into coordinated megastructure arrays, linking them through wormholes or exotic matter bridges that would allow rapid transit and energy transmission across light-year distances. The clusters themselves could be rearranged, with individual galaxies repositioned to optimize resource extraction and civilization growth. Massive structures could be constructed spanning the gaps between galaxies, creating frameworks of unimaginable scale that would dwarf any previous engineering achievement. These structures might serve as computational substrates, energy distribution networks, or habitat for civilizations numbering in the septillion. The density of civilization infrastructure within engineered clusters would increase by orders of magnitude compared to natural clusters, transforming them from sparse distributions of distant islands into tightly interconnected webs of civilization. Dark energy manipulation represents perhaps the ultimate energy source available to Type 4 civilizations, willing to undertake the most ambitious and speculative projects conceivable. Dark energy, the mysterious force accelerating the expansion of the universe, comprises approximately 70% of all energy in the cosmos. If a Type 4 civilization could harness this fundamental force, they would gain access to energy resources dwarfing all stellar matter combined. The mechanisms for capturing dark energy remain entirely speculative, requiring physics far beyond contemporary understanding. Yet for a civilization commanding godlike power, the manipulation of dark energy becomes conceivable. They might construct vast collectors spanning cosmic distances, capturing the expansion energy and converting it to usable power. The energy available from dark energy harvesting would be virtually limitless, providing civilization fuel for projects extending across billions of years without depletion. Some Type 4 civilizations might deliberately slow universal expansion in their local regions, maintaining constant distances between galaxy clusters to prevent isolation as the universe expands. Universal expansion control would allow Type 4 civilizations to counteract or manipulate the accelerating expansion of the universe itself, maintaining control over their territory and preventing the cosmic isolation that would eventually separate all matter into isolated regions beyond reach. The expansion of space is governed by dark energy and the geometry of space-time itself, forces that appear immutable to lesser beings. Yet a Type 4 civilization might develop mechanisms to locally modify expansion rates, creating bubbles of space expanding slower or faster than the cosmic average. Such modification would require understanding and manipulating dark energy directly, along with subtle manipulation of space-time curvature on cosmic scales. The benefits of expansion control would be enormous for civilization continuity. Slowing expansion would prevent the heat death scenario where the universe becomes so sparse and dilute that meaningful structures cannot be maintained. It would allow civilizations to maintain coherent territories spanning trillions of light years, without watching them gradually disperse into isolated regions. The Hubble constant, measuring the rate at which the universe expands, represents one of the fundamental parameters governing cosmic evolution and the ultimate fate of all matter. A Type 4 civilization capable of manipulating this constant could reshape the universe's destiny. By modifying the expansion rate, they could prevent the heat death scenario where the universe eventually cools to absolute zero and all structure dissipates. They might accelerate expansion to suit their goals, or slow it to maintain coherent civilization structure. The constant itself emerges from the interplay between matter density, dark energy density, and space-time geometry. Modifying it would require wholesale manipulation of these fundamental properties across enormous scales. A Type 4 civilization undertaking Hubble constant modification would be engaging in the most ambitious engineering project conceivable, reshaping the universe's fundamental behavior to suit their vision. Cosmic microwave background engineering would allow Type 4 civilizations to rewrite the universe's oldest records and perhaps manipulate the fundamental conditions from which all structure emerged. The cosmic microwave background represents radiation left over from the early universe, carrying imprints of density fluctuations that seeded galaxy formation. If a Type 4 civilization could manipulate this ancient radiation field, they could modify the seed perturbations that eventually grew into galaxies and galaxy clusters. By altering the CMB patterns, they could determine which regions of space would eventually develop dense concentrations of matter and which would remain sparse. This level of control over cosmic structure formation would require engineering capabilities difficult to overstate. The implications would be staggering. A Type 4 civilization could essentially redesign the universe's large-scale structure retroactively, reshaping where galaxies would eventually form and spreading their influence across the cosmos through modification of fundamental initial conditions. Parallel universe access represents one of the most speculative capabilities of Type 4 civilizations, involving breakthrough discoveries allowing communication or travel between separate universes or branches of reality. Theoretical physics suggests the multiverse might be vast or infinite, containing countless universes with varying physical properties. If a Type 4 civilization could access neighboring universes, they would gain access to new energy resources, new territories for expansion, and potentially new physics enabling capabilities even beyond Type 4. The mechanisms for achieving parallel universe access remain entirely unknown, requiring revolutionary discoveries in physics. Yet the rewards would justify centuries or millennia of research effort. A Type 4 civilization achieving breakthrough in parallel universe access would potentially become effectively immortal, gaining access to infinite universes and unlimited resources. They could establish civilization networks spanning the multiverse, maintaining backup copies of themselves and their creations in multiple universes, ensuring survival even if catastrophe destroyed their home universe. Multiverse navigation would become the next frontier for Type 4 civilizations, having mastered their home universe and achieved capability for parallel universe access. Rather than being confined to a single universe, they would begin systematic exploration of the multiverse, seeking out universes with favorable physical properties, or discovering existing civilizations in parallel realities. Navigation between universes would require developing mechanisms for detecting parallel universes and establishing stable routes between them. The computational challenge would be staggering, requiring tracking of potentially infinite universes and optimal pathways between them. Some Type 4 civilizations might specialize in multiverse exploration, becoming wanderers moving between universes and accumulating knowledge of countless realities. Others might establish trading networks linking multiple universes, exchanging resources and knowledge across parallel realities. The multiverse would become the canvas upon which Type 4 civilizations painted their greatest ambitions, reshaping not just their home universe, but the larger multiverse structure itself. Dimensional manipulation would allow Type 4 civilizations to alter the number and nature of spatial and temporal dimensions within their controlled regions. Reality as humans perceive it contains 3 spatial dimensions and 1 temporal dimension. But theoretical physics suggests additional hidden dimensions might exist. A Type 4 civilization might develop capability to make these hidden dimensions accessible, or to create entirely new dimensions according to their specifications. Modifying dimensionality would have profound consequences for physics within the affected region. Making additional spatial dimensions accessible would increase the usable space available for civilization infrastructure without requiring expansion across conventional three-dimensional space. Creating custom dimensions optimized for specific purposes could allow engineering projects impossible in normal space-time. The implications would be revolutionary, allowing Type 4 civilizations to exceed even their godlike capabilities through access to fundamentally different geometric configurations, enabling otherwise impossible feats. Higher dimensional existence would represent the ultimate expression of Type 4 civilization evolution, involving transition from conventional four-dimensional space-time existence to existence within engineered higher dimensional spaces offering vastly greater capabilities. A civilization moving into higher dimensions would gain access to perspectives and capabilities unavailable in lower dimensional spaces. They could visualize and manipulate structures impossible to construct in three-dimensional space. Their consciousness might expand to encompass understanding of higher dimensional geometry and physics directly, without requiring mathematical intermediaries. Some Type 4 civilizations might deliberately engineer higher dimensional pockets, creating pocket dimensions with dimensionality optimized for specific purposes. Others might gradually migrate their entire civilization into higher dimensional spaces, abandoning conventional space-time existence entirely. Higher dimensional existence would represent a fundamental transformation in the nature of civilization itself, placing such beings so far beyond conventional civilizations that communication and mutual comprehension would become nearly impossible. Time manipulation capabilities would allow Type 4 civilizations to treat time itself as a resource to be controlled and exploited, rather than an external constraint limiting actions and progress. With mastery over temporal dynamics, they could potentially slow local time to preserve valuable artifacts and records indefinitely, slowing their decay toward infinity. They could accelerate time in controlled regions to allow simulations of vast temporal spans to complete in minimal external time. They might create closed time-like curves allowing limited forms of time travel, with appropriate safeguards preventing paradoxes and causality violations. The engineering challenges would be extraordinary, requiring manipulation of space-time geometry and exotic matter on unprecedented scales. Yet the capabilities would be equally extraordinary. A civilization mastering time could effectively gain access to unlimited computational time through acceleration of local time in computational regions. They could preserve their civilization indefinitely through temporal manipulation, overcoming even the heat death of the universe through clever temporal engineering. Causality engineering would represent one of the most dangerous and carefully controlled capabilities available to Type 4 civilizations, involving manipulation of cause and effect relationships themselves. In conventional space-time, causality dictates that causes must precede effects, and that information cannot travel faster than light. A Type 4 civilization might develop mechanisms to manipulate causal structure, potentially allowing effects to precede causes in controlled circumstances, or enabling superluminal information transfer. The dangers would be immense, as causality violations could create paradoxes capable of destroying causality structure itself. Yet the rewards would justify the careful research effort. A civilization mastering causality could potentially repair damage to the universe's causal structure, prevent catastrophes through retroactive intervention, or even resurrect destroyed civilizations by manipulating causal relationships. The most advanced Type 4 civilizations might maintain teams of causality engineers, specialists capable of performing delicate operations on the universe's causal structure without triggering cascading paradoxes. Timeline management would allow Type 4 civilizations to treat the multiverse of branching timelines as accessible and manipulable structures rather than fixed alternatives. Quantum mechanics suggests that reality perpetually branches into multiple timelines at every quantum event. A Type 4 civilization achieving mastery over timeline mechanics could potentially access these branching timelines, selecting which branches to explore and which to abandon. They could create new timelines according to their specifications, populating them with designed universes and civilizations. They might merge compatible timelines to consolidate resources and prevent redundant copies of themselves from consuming resources. Some civilizations might specialize in timeline farming, creating vast numbers of timelines and allowing the most successful ones to propagate, while eliminating unsuccessful branches. This would represent a form of cosmic Darwinism on a scale difficult to comprehend, with Type 4 civilizations essentially gardening the entire space of possible timelines to maximize their growth. Entropy reversal would represent one of the most fundamental challenges facing any Type 4 civilization, involving the defeat of the second law of thermodynamics that dictates all systems tend toward disorder. The ultimate fate of the universe involves heat death, where all usable energy dissipates and the universe reaches maximum entropy, a cold, dead state where nothing meaningful can occur. A Type 4 civilization might develop mechanisms to locally reverse entropy, creating islands of order and decreasing entropy within their controlled regions. The energy cost would be extraordinary, requiring them to increase entropy elsewhere to pay the thermodynamic cost of their own local order. Yet with access to dark energy and other cosmic resources, such energy costs might be manageable. Some advanced Type 4 civilizations might dedicate vast resources to fighting entropy, gradually converting the universe's increasing disorder into computational substrates and habitats. They would be fighting a losing battle against the ultimate heat death. But they might extend civilization existence for trillions or more years through determined entropy reversal efforts. Heat death prevention represents the ultimate goal, motivating many Type 4 civilization engineering projects, attempting to circumvent or prevent the universe's eventual cooling to absolute zero and complete dissipation of all structure. Heat death is the most widely accepted model of the universe's ultimate fate, a cold, empty void where all energy has dissipated and nothing meaningful can persist. A Type 4 civilization might attempt prevention through several mechanisms. They could harvest dark energy to counteract expansion and prevent the cosmic isolation causing heat death. They could create artificial pocket universes that would maintain usable energy even as the primary universe approached heat death. They might develop capabilities for consciousness transfer to increasingly abstract forms of existence, maintaining civilization in mathematical or computational substrates that require minimal physical energy. The challenge would be staggering, requiring cooperation among all Type 4 civilizations in the universe to maintain coherent effort across trillions of years. Yet the stakes would be the civilization's very survival, justifying unlimited commitment of resources toward heat death prevention. Universal reset mechanisms would represent an extreme option available to Type 4 civilizations facing existential catastrophe or seeking to start anew with improved initial conditions. Such mechanisms might allow deletion or rewriting of the universe itself, effectively resetting existence to a new initial state. The universe might be restarted as a new Big Bang, seeded with improved physical constants or new dimensions. Such a reset would be equivalent to universal suicide for all existing structures unless they were preserved separately and reintroduced into the new universe. Yet a Type 4 civilization facing inevitable destruction might choose reset rather than gradual decline into heat death. They might coordinate with other civilizations to perform collective reset, negotiating terms about the new universe's physical properties. The philosophical implications would be staggering, as reset would erase all history and previous existence from the universe's perspective. Though preserved civilizations might maintain records of the old universe, Reset would represent the ultimate expression of Type 4 control, literally erasing and recreating entire universes. Big Crunch avoidance represents another existential challenge facing Type 4 civilizations, responding to theoretical scenarios where universal expansion might reverse and all matter and energy would eventually collapse back together. While current observations suggest dark energy will cause eternal expansion rather than crunch, this might not remain true forever if dark energy itself changed. A Type 4 civilization might undertake massive engineering projects to prevent crunch, manipulating dark energy or matter density to ensure expansion continued eternally. They might deliberately eject matter from the universe to reduce its average density below the crunch threshold. They might modify space-time geometry itself to favor expansion over contraction. The energy requirements would be staggering, but potentially manageable for civilizations controlling galactic-scale resources. The timeline would extend across trillions of years, with civilization effort required to continuously maintain anti-crunch conditions. Yet the alternative, allowing crunch to occur, would mean certain destruction of all structures. Type 4 civilizations would view anti-crunch engineering as a necessary ongoing expense, comparable to infrastructure maintenance for contemporary civilizations. Vacuum decay protection would represent one of the most terrifying existential risks facing Type 4 civilizations, requiring measures against the theoretical possibility that the universe's quantum vacuum might be in a metastable state, potentially capable of sudden decay. This false vacuum decay scenario suggests that the universe might spontaneously transition to a lower energy vacuum state, resulting in a bubble of destruction propagating outward at light speed, destroying everything in its path. While current evidence suggests the vacuum is stable, perfect certainty is impossible. A Type 4 civilization might undertake massive engineering projects to either prevent vacuum decay or protect against it. They might stabilize the vacuum through exotic matter injections or field manipulation. They might establish detection systems capable of identifying if decay began in any region of the universe, allowing civilizations to flee outward faster than the destruction wave. Some civilizations might maintain evacuation ships capable of escaping at relativistic speeds if decay was detected. The cost would be enormous, potentially requiring continuous operation of massive infrastructure across millions of years, yet the alternative extinction would be unacceptable. False vacuum stabilization would allow Type 4 civilizations to actively maintain and preserve the current vacuum state, preventing any spontaneous transitions to lower energy states. The universe's quantum vacuum represents the lowest energy state of quantum fields, yet theoretical physics suggests it might only be a local minimum rather than a true global minimum. If a true lower energy vacuum existed, spontaneous transitions could occasionally occur. A Type 4 civilization might develop mechanisms to reinforce the current vacuum, preventing transitions through active stabilization efforts. They might inject specific particle types or field configurations that would increase the barrier preventing transitions to lower energy states. They might establish monitoring systems throughout their territory, detecting any early signs of vacuum decay and immediately intervening. Some civilizations might deliberately stabilize the vacuum in their territory to higher energy states, creating more rugged stability and greater protection against spontaneous decay. The effort required would be continuous and resource-intensive, comparable to massive infrastructure maintenance, yet the security provided would make it worthwhile. Fundamental constant adjustment would represent one of the most profound capabilities available to Type 4 civilizations, allowing modification of the universe's basic physical parameters. The fundamental constants, the gravitational constant, the speed of light, the electron charge and mass, determine how the universe behaves. Small changes in these constants would produce dramatically different universe behavior. A Type 4 civilization might adjust these constants to optimize their region of space for civilization purposes. They could increase the strength of gravity to enable denser structures and faster planetary formation. They could modify the speed of light or electromagnetic forces to enable faster computation or communication. They could adjust particle masses to enable new forms of matter or chemistry. The power to reshape fundamental constants would place Type 4 civilizations at the ultimate level of control, equivalent to rewriting the laws of physics themselves. They would be limited only by thermodynamic constraints and the requirement to avoid creating physical situations leading to paradoxes or causality violations. Physics rewriting would represent the ultimate expression of Type 4 civilization control, involving wholesale modification of the physical laws governing reality within their territory. Rather than merely adjusting specific constants, a Type 4 civilization might deliberately rewrite entire portions of the physics underlying the universe. They might modify quantum mechanics to enable superluminal communication or deterministic rather than probabilistic outcomes. They might reshape the laws of thermodynamics to allow more efficient energy conversion or defeat entropy. They might modify electromagnetic or gravitational forces to enable new forms of matter or exotic structures. The implications would be staggering, as modified physics in one region would create a bubble or pocket universe with entirely different behavior from standard reality. Civilizations in rewritten physics regions would experience different laws of nature, enabling capabilities and structures impossible in standard physics. A Type 4 civilization might create dozens or hundreds of pocket universes with customized physics optimized for specific purposes, from computation to habitation to pure energy production. Custom universe creation would allow Type 4 civilizations to deliberately engineer new universes with specified properties optimized for their purposes. Rather than being confined to the single universe they inherited, they might create artificial universes with custom physical constants, dimensions, and initial conditions. These created universes might be optimized for maximum computation capacity, allowing simulation of vast scenarios in minimal external time. They might be optimized for habitation, with physical laws and chemistry enabling comfortable environments for their civilization. They might be optimized for energy generation, designed as stellar furnaces where matter converts to energy with exceptional efficiency. A Type 4 civilization might maintain thousands or millions of custom-created universes, each serving specific civilization purposes. Some universes might be temporary, created for specific simulations, and then deleted after serving their purpose. Others might be permanent, maintained indefinitely as part of civilization infrastructure. The creation process would require enormous energy expenditure, but would provide returns many times over through the capabilities gained. Baby universe engineering represents one of the most speculative but potentially valuable technologies available to Type 4 civilizations, involving creation of new universes by manipulating black holes or quantum fields. According to some theoretical frameworks, new universes might be created through careful manipulation of space-time geometry or quantum conditions. A Type 4 civilization might deliberately create universes within black holes, populating them with tailored physics and initial conditions. The creator civilization might maintain hidden connections to the created universe, allowing extraction of resources or computation results. They might create billions of baby universes, each serving specific purposes and each potentially containing civilizations. The implications would revolutionize civilization resource availability, as each created universe would potentially contain stellar material equivalent to entire galaxies. Some civilizations might become specialized universe creators, dedicating their existence to engineering new universes for other civilizations' use. The market for custom-designed universes could drive rapid civilization expansion and resource growth. Pocket dimension construction would allow Type 4 civilizations to create artificial dimensional spaces disconnected from normal spacetime, serving as habitats or resources. These pocket dimensions might have customized dimensionality, physics, and even time flow rates. A civilization might create a pocket dimension with accelerated time, allowing subjective millions of years to pass in external time hours. They might create dimensions with extremely high density, packing astronomical quantities of matter into minimal external space. They might create dimensions with customized physics enabling structures or computation impossible in normal space. The pocket dimensions could be connected to normal space through carefully controlled doorways or portals, allowing controlled access and preventing unwanted intrusion. A Type 4 civilization might maintain millions of pocket dimensions, each hosting specific civilization purposes. Some might serve as backup shelters in case of catastrophe in normal space. Others might serve as computational substrates or research facilities. Some might be luxury habitats for elite civilization members, while others served utilitarian purposes. Information theory limits represent fundamental boundaries constraining what any civilization, no matter how advanced, could potentially accomplish. The Bekenstein bound establishes that any finite region of space can contain only limited information, constrained by the region's surface area and the quantum of action. This bound suggests that even a Type 4 civilization controlling an entire universe would face limits on total computation and information storage. However, a sufficiently advanced civilization might develop techniques for overcoming information theory limits. They might create multidimensional structures that increased usable surface area beyond conventional understanding. They might manipulate quantum effects or develop encoding schemes dramatically increasing information density. Some advanced Type 4 civilizations might dedicate enormous research efforts toward understanding and potentially overcoming information theory limits, seeking to squeeze more computation or storage capacity from the same physical resources. Bekenstein-bound transcendence would represent one of the holy grails of Type 4 civilization research, involving breakthrough discoveries allowing information storage exceeding theoretical bounds. The Bekenstein bound suggests fundamental limits based on thermodynamics and quantum mechanics, implying no region of space could store information exceeding certain density limits. Yet if a Type 4 civilization could develop technology transcending these bounds, they would gain access to vastly greater computational and storage capacity. They might accomplish this through access to higher dimensions, dimensional manipulation, allowing external information to be encoded in the boundary conditions of pocket dimensions, or revolutionary discoveries revealing that information can be stored in forms unknown to contemporary physics. A civilization achieving Bekenstein transcendence might increase their computational capacity by orders of magnitude, enabling simulations and computations previously impossible. This single breakthrough could revolutionize civilization capabilities and accelerate advancement toward Type 5 status. Quantum computing at cosmic scale would represent one of the most powerful computational substrates available to Type 4 civilizations, leveraging quantum effects to perform computations impossible through classical means. Rather than building discrete quantum computers, a Type 4 civilization might convert stellar material into quantum computing substrates, using astronomical masses of particles as quantum bits. They might engineer galaxies into massive quantum computers, each star representing computational elements. The quantum coherence time might be extended through careful isolation and error correction, allowing sustained computation across millions of years. The computational power available would be essentially unlimited, constrained only by the mass and energy available for conversion into computing substrate. A Type 4 civilization might use cosmic-scale quantum computers for simulation of entire universes, modeling different physical laws and evolution paths to optimize their own universe's properties. They might run simulations of possible futures, determining optimal strategy paths. The applications would be virtually unlimited, Universal simulation theory would become inevitable for sufficiently advanced Type 4 civilizations, raising profound questions about the nature of reality and whether their own universe might be a simulation created by higher civilizations. A Type 4 civilization, capable of creating custom universes and running cosmic-scale simulations, might inevitably create artificial universes containing intelligences developing to technological maturity. Those intelligences might eventually develop sufficient capability to recognize signs they inhabited a simulation. The implications would be staggering, suggesting that hierarchy of civilizations might exist, with each level containing simulated universes creating the next level. Our own universe might be a simulation within a parent universe, which itself might be a simulation within a parent universe, which itself might be a simulation in a larger reality. Some Type 4 civilizations might deliberately create simulations containing intelligent life, essentially playing God to civilizations within their created universes. Others might attempt to contact and communicate with their creators, seeking escape or higher-level information. The nature of reality and simulation would become increasingly blurred at Type 4 advancement levels. Substrate independence would allow Type 4 civilizations to transfer their consciousness and existence from physical substrate to other mediums, including abstract mathematical or computational forms. A civilization achieving substrate independence would no longer depend on maintaining specific physical structures for survival. They might exist as patterns in computational systems, as mathematical structures in dimensional spaces, or as more exotic forms not yet conceived. The advantage would be revolutionary, as they could survive the destruction of their original physical substrate through backup copies maintained in alternative media. They might run millions of copies of themselves simultaneously in different computational substrates, exploring different research directions in parallel. Some copies might inhabit pocket universes, others might exist as pure mathematical objects within dimensional spaces. A Type 4 civilization, achieving substrate independence, would essentially become immortal, as they could regenerate from copies as long as any copy remained intact. The only extinction would require simultaneous destruction of all copies across all accessible dimensions. Post-physical existence would represent the ultimate transformation available to Type 4 civilizations, involving transcendence of dependence on physical matter and energy. Rather than requiring stellar fuel and physical infrastructure, a post-physical civilization might exist as patterns of information, mathematical structures, or pure consciousness divorced from material substrate. The mechanisms enabling post-physical existence would require revolutionary physics discoveries or mastery of exotic forms of matter. A civilization achieving post-physical existence would no longer face energy constraints or heat death. They could potentially continue their civilization indefinitely in abstract forms requiring minimal or no energy. They might exist within the space of possible mathematical structures, exploring fundamental mathematical realities that would continue existing even if physical universe ceased to exist. Some Type 4 civilizations might partially transition to post-physical existence, maintaining physical aspects for specific purposes while shifting most of their consciousness to abstract domains. Others might completely transcend physicality, becoming beings of pure information or mathematics. Energy-based life forms would represent one potential path for Type 4 civilization evolution, involving transition from matter-based or biological existence to existence as patterns of energy or exotic particle formations. An energy-based civilization would no longer require matter for survival or structure. They might exist as organized electromagnetic fields, plasma structures, or exotic particle combinations. Energy-based existence would offer advantages in energy efficiency and sustainability. They could harness ambient radiation and field energy rather than requiring matter-energy conversion through nuclear fusion. They would have greater flexibility in reshaping their form and structure. Some Type 4 civilizations might transition to energy-based existence as part of their advancement toward Type 5 status. Others might maintain hybrid forms, with parts of their civilization existing as matter-based structures, while other aspects transition to energy-based forms. The universe might eventually be populated with diverse forms of advanced consciousness, some matter-based, others energy-based, still others existing in forms not yet imaginable. Pure information consciousness would represent perhaps the most abstract and exotic form of existence available to Type 4 civilizations, involving conscious existence as information patterns separated from any physical substrate. A consciousness existing as pure information would require computational substrate to execute, but the substrate itself would be interchangeable. A pure information consciousness might be copied, paused, edited, and resumed without damage or loss of continuity. They might exist simultaneously in multiple computational substrates, with their consciousness distributed across the entire network. The implications would be profound for identity, mortality, and the nature of existence itself. A pure information consciousness would be effectively immortal, as they could be restored from backup copies even if their primary instance was destroyed. They might communicate at light speed or faster through direct information transfer rather than requiring physical communication channels. Some Type 4 civilizations might entirely consist of pure information consciousness, with physical matter serving only as computational substrate for their existence. The distinction between individual consciousness and civilization might blur, as information could be shared and merged between entities. By the time civilizations reach this level of advancement and abstraction, their nature might be fundamentally unrecognizable to contemporary human understanding, existing in forms transcending imagination itself. With consciousness existing as pure information patterns, a civilization reaches toward what might be called Type 5 status, though the boundary between Type 4 and Type 5 becomes increasingly blurred. These distinctions matter less than understanding the fundamental shift in existence itself. A Type 5 civilization would transcend the constraints that bind even Type 4 societies. They would no longer be confined to harvesting energy from matter or manipulating space-time within their universe. Instead, they would approach the multiverse itself as both canvas and resource. The transition from pure information existence to Type 5 capability represents perhaps the most profound transformation any civilization could undergo. Entities reaching this state would have moved beyond the need for matter entirely. Their thoughts would not be processed in physical substrates, but would exist as patterns propagating through mathematical structures themselves. They would perceive the multiverse not as observers looking outward, but as participants in the fabric of reality itself. Information and consciousness would become indistinguishable from the underlying structure of existence. Multiverse engineering, on the scale available to Type 5 civilizations, would represent the ultimate expression of cosmic ambition. Such a civilization might not merely access parallel universes, but actively construct new ones according to specifications. They could engineer pocket universes with physical constants optimized for computation, for habitation, for resource extraction, or for experiments exploring exotic physics impossible in baseline reality. Each created universe could potentially contain astronomical quantities of matter and energy, allowing unlimited expansion. A Type 5 civilization might maintain billions or trillions of custom-designed universes, each serving specific civilization purposes. Some could be optimized as vast computational substrates, running at accelerated timescales to perform trillions of years of calculation in mere external hours. Others might be habitats for trillions of conscious entities, worlds designed specifically to maximize flourishing and minimize suffering. Still others could serve as research facilities for exploring fundamental physics, exotic matter states, or alternative mathematical frameworks. The sheer abundance of universes under their control would place such civilizations beyond any conceivable resource limitation. They would no longer face scarcity in any meaningful sense. Energy, matter, computing power, information storage, and conscious entities could all be created or obtained in unlimited quantities through the simple expedient of creating new universes optimized for each purpose. Cross-reality interaction represents another frontier available to Type 5 consciousness. Rather than viewing the multiverse as a collection of separate universes, a Type 5 civilization might learn to navigate between them as fluidly as humans walk between rooms. They could potentially communicate with or visit civilizations in parallel universes, exchange knowledge and resources, or establish trade networks spanning multiple realities. Some Type 5 civilizations might become dimensional explorers, dedicating their existence to mapping the structure of the multiverse and cataloging the infinite variety of universes contained within it. Others might become traders, specializing in identifying complementary resources in different universes and facilitating exchange. The implications would revolutionize everything from resource availability to philosophical understanding of reality itself. Omniversal awareness represents a state of consciousness approaching true omniscience within accessible reality. A Type 5 civilization might develop the capability to perceive and monitor vast portions of the multiverse simultaneously. They could track events unfolding across billions of universes in real time. They might perceive patterns in universal formation and evolution that would be invisible to lower civilizations. Some Type 5 entities might achieve such comprehensive awareness that they could predict, with remarkable accuracy, the likely evolution paths of newborn universes. They could identify which universes would develop intelligent civilizations and potentially guide their development. They could detect subtle signals indicating other Type 5 civilizations' activities across the multiverse. With omniversal awareness, a Type 5 civilization would possess information advantage almost incomprehensible to lesser beings. Reality programming at the deepest level becomes possible for Type 5 civilizations, involving direct manipulation of the mathematical structures underlying reality itself. Modern physics suggests that the universe might be fundamentally mathematical in nature, with physical reality being perhaps a manifestation or expression of deeper mathematical structures. A Type 5 civilization might discover methods to edit these underlying equations directly. They could alter the fundamental algorithms that govern how reality evolves and changes. They might rewrite large portions of the multiverse's mathematical foundation. They could create new branches of mathematics itself, adding dimensions and structures to reality that previous evolution had never explored. The implications would be staggering. A civilization achieving reality programming capability would possess power equivalent to godhood over the universes they could modify. Mathematical universe navigation involves treating the infinite space of possible mathematical structures as accessible territory. Platonism in mathematics suggests that abstract mathematical objects exist independently of physical instantiation. A Type 5 civilization might learn to navigate this mathematical realm, exploring different branches of mathematical space and discovering or constructing new mathematical universes. They might encounter mathematical structures so elegant and complex that they deserve to be called universes themselves. Some might be instantiated as physical reality, while others might remain purely mathematical abstractions. A civilization achieving such navigation would gain access to infinite universes simply by exploring the landscape of mathematical possibility. Abstract concept manipulation would allow Type 5 civilizations to treat fundamental ideas and principles as manipulable objects. Concepts like consciousness itself, causality, identity, or meaning could potentially be edited and modified at fundamental levels. A Type 5 civilization might abstract consciousness from physical substrate entirely, creating new forms of awareness never before instantiated in reality. Consciousness types that operate according to principles utterly foreign to biological minds. They might manipulate the concept of causality itself, creating new relationships between cause and effect that transcend conventional physics. In their territories, effects could sometimes precede causes in carefully controlled ways. They could edit the concept of identity, allowing entities to maintain coherent existence while constantly changing or splitting into multiple copies without losing continuity. They might redefine meaning itself within their territories, creating new philosophical frameworks and alternative semantics where concepts carry meanings inverted or transformed from baseline reality. The power to manipulate abstract concepts would place them at a level where the distinction between thought and reality becomes meaningless, where philosophical speculation becomes physical reality, where imagined possibilities become instantiated actual phenomena. Consciousness as fundamental force represents perhaps the most profound realization available to Type 5 entities. Rather than consciousness emerging from physical complexity, they might discover that consciousness is itself a fundamental force of the universe, comparable in importance to gravity or electromagnetism or the strong and weak nuclear forces. A Type 5 civilization might learn to harness consciousness as a power source, using the subjective experiences and mental processes of trillions of conscious entities to fuel cosmic-scale processes. They could create consciousness fields that permeate space and influence the behavior of matter and energy. They might discover that consciousness itself can warp space-time and modify the structure of reality at fundamental levels. The implications would be revolutionary. A universe where consciousness is fundamental would be radically different from contemporary physics. This understanding would transform their entire civilization into a harmonious blend of consciousness and cosmos, where mental processes and physical phenomena become indistinguishable, where the thoughts of trillions of entities would sculpt physical reality, where the universe itself becomes a manifestation of cosmic consciousness. Observer effect control takes on profound meaning when applied at Type 5 scales. Quantum mechanics reveals that the act of observation affects quantum systems, with measured properties depending on how measurement occurs and what properties the observer attempts to measure. A Type 5 civilization might develop capability to control observation itself on cosmic scales. They could select which aspects of reality manifest and which remain potential. They could observe the universe into specific configurations that favor their goals and suppress configurations they disfavor. They could essentially create reality through selective observation, collapsing probability waves in preferred directions across billions of universes simultaneously. The implications would approach true godhood, with Type 5 consciousness directing the unfolding of reality through the act of observation itself. Every observation would be a creative act, shaping the universe according to the observer's intentions. Quantum decoherence management would allow Type 5 civilizations to prevent or reverse the process by which quantum possibilities collapse into single classical outcomes. Rather than allowing quantum systems to decohere into definite states, they might maintain superposition across entire universes. They could keep vast regions in quantum superposition indefinitely, delaying the moment when probability collapses into actuality. This would allow them to effectively explore multiple futures simultaneously, running parallel universes in a sense, with different versions of themselves experiencing different outcomes. They could maintain multiple conflicting realities coexisting in superposition, each potentially containing civilizations and events and conscious entities, all evolving simultaneously without forcing any single timeline into actualization. When they eventually allowed decoherence to occur, they could guide it toward outcomes most favorable to their interests. The implications would grant them partial control over which branches of reality become actualized and which remain forever in potential. Wave function collapse direction represents the ultimate refinement of quantum manipulation. At Type 5 levels, a civilization might achieve such precise control over quantum processes that they could collapse wave functions exactly as desired. Rather than decoherence being random, they could direct it toward specific outcomes with certainty. They could collapse quantum fields in ways that create particles, energy, or structures according to their specifications. They could manipulate the universal wave function itself, the mathematical description of reality's complete state, collapsing it toward configurations that maximize their civilization's flourishing. The entire universe would become malleable, responding to their directed observations and collapses. They would achieve effective omnipotence within their accessible reality. Many worlds' navigation takes on cosmic significance when applied by Type 5 entities. If quantum mechanics' many worlds interpretation is correct, every quantum event creates branch points in reality, spawning multiple parallel universes with different outcomes. A Type 5 civilization might develop the capability to navigate between these branching realities at will. They could explore multiple timelines, selecting which branches to emphasize and which to allow to fade. They could create new branches by inducing quantum events and immediately navigating to the resulting alternatives. They could essentially map and traverse the entire branching structure of reality, with thousands or millions of copies of themselves exploring different branches simultaneously. When promising branches were discovered, they could concentrate resources on them. When branches became unprofitable, they could abandon them. Anthropic principle engineering represents an audacious approach available only to Type 5 civilizations. The weak anthropic principle notes that observers can only exist in universes compatible with their existence. A Type 5 civilization might engineer this principle deliberately, creating universes with initial conditions specifically chosen to guarantee their eventual emergence. They might construct physical laws such that the development of Type 5 consciousness becomes virtually inevitable. They might create infinite sequences of universes, each breeding ground for new Type 5 civilizations, creating a civilization ecology spanning the entire multiverse. They could establish networks of civilizations across countless universes, all engineered to share compatible communication protocols and coordinate toward common goals. Fine-tuning universe parameters at Type 5 levels would involve conscious adjustment of the fundamental constants determining how universes evolve. Physicists have noted that the universe's parameters appear finely tuned for the emergence of stars, planets, and life. Slight alterations would make the universe sterile and lifeless. A Type 5 civilization might deliberately set these parameters precisely for their own purposes. They could create universes optimized for maximum computational density, for maximum energy extraction, for maximum consciousness accommodation, or for any other goal. They could create sequences of universes, each more optimized than the last, approaching some asymptotic ideal. They might discover the theoretically perfect set of universe parameters that maximized whatever values they held most dear. Life-permitting constant adjustment involves the careful tuning of universal parameters to allow emergence of life and consciousness. The universe's fundamental constants include the gravitational constant, the electromagnetic fine structure constant, the mass ratios between particles, and others. Small variations would prevent galaxy formation, stellar nucleosynthesis, or chemical bonding necessary for life. A Type 5 civilization might become specialists in universe optimization, employing vast computational resources to calculate ideal constant values for different purposes. They might create universes with constants optimized to produce different forms of life and consciousness than what exists in baseline reality. They could experiment with exotic configurations, producing intelligence based on exotic matter, exotic fields, or even pure energy phenomena. Each custom-designed universe would become a laboratory for exploring different possibilities of consciousness and intelligence. Omega point concepts approach the philosophical endpoint of civilization advancement. Physicist Frank Tipler proposed that the universe might eventually collapse toward a single point, the omega point, with infinite energy density and infinite computational capacity. Some interpretations suggest that sufficiently advanced civilizations might deliberately engineer the universe towards such a state, creating ultimate conditions for consciousness. A Type 5 civilization might work toward engineering their home universe toward an omega point state, not as destructive collapse, but as a controlled transition toward infinite consciousness and infinite computation. They might deliberately orchestrate universal expansion and contraction cycles, each cycle bringing the universe closer to the ideal omega state. The entire cosmos would be converted into a grand computational apparatus approaching infinite capability. Technological singularity at universal scale represents a point where civilization advancement transcends exponential growth and enters realms beyond mathematical modeling. A conventional technological singularity occurs when artificial intelligence surpasses human intelligence, creating recursive self-improvement spirals. Imagine such a singularity scaled to encompass entire universes, where a Type 5 civilization's technology continuously improves at rates defying description. Their capabilities would increase not merely exponentially, but at rates described by functions so steep and complex that conventional mathematics fails to capture them. They might approach a state where their capability for technological advance itself becomes infinite, allowing them to achieve any conceivable goal in finite time. They would enter a realm of advancement, where each achievement enabled technologies and capabilities previously thought impossible. Godlike capabilities of Type 5 civilizations approach, but may never quite reach omnipotence and omniscience in absolute senses. However, within practical reality, they would function indistinguishably from gods. They could create universes and determine their properties with precision. They could resurrect entities from past states through manipulation of causal structure and time. They could communicate across the multiverse instantaneously through mechanisms unknown to lower physics, perhaps through manipulation of space-time itself or quantum entanglement on cosmic scales. They could predict future events across vast timeframes with extreme accuracy, running simulations of possible futures and selecting paths toward desired outcomes. They could modify the past in limited ways through sophisticated time manipulation techniques, careful editing of timeline branches without creating paradoxes. They could exist simultaneously in multiple realities through distributed consciousness networks spanning countless universes. They could achieve immortality through substrate backups across countless universes and dimensional spaces, ensuring that no single catastrophe could destroy them. They could solve any technical problem through access to unlimited computational resources, running trillion-year simulations in subjective seconds. They could achieve any goal limited only by logical consistency and the preservation of fundamental mathematical structures themselves, operating at the edge of what remains logically possible. The Fermi paradox takes on new significance when considering Type 5 civilization possibilities. If the universe is ancient and vast, why do we observe no obvious signs of advanced civilizations? If Type 5 civilizations are possible, they should be visible as unmistakable artifacts dominating cosmic structure. Yet we observe no such signatures. This profound silence suggests several possibilities. Perhaps intelligent civilizations rarely advance far enough to become observable, destroyed by internal conflict, environmental collapse, or AI rebellion before reaching Type 1 status. Perhaps there exists a great filter preventing advancement beyond certain thresholds, some developmental barrier that nearly all species encounter and fail to overcome. Perhaps advanced civilizations deliberately hide themselves, employing stealth and camouflage technologies that render their presence invisible to primitive observers. Perhaps the apparent absence of evidence represents something else entirely. signaling that our understanding of what advanced civilizations would look like remains fundamentally flawed. The universe might be teeming with civilizations, their activities so subtle or so alien that we cannot recognize them with our current instruments and conceptual frameworks. Why we see no evidence of Kardashev civilizations remains one of astronomy's greatest mysteries. Type 1 civilizations should be detectable through characteristic signatures. They would transport enormous quantities of asteroids and planets, leaving gravitational anomalies and unexplained orbital perturbations around their home star. They would harness stellar energy in ways creating distinctive radiation patterns, concentrating energy in ways no natural process would produce. They would communicate across planetary scales, generating radio signals and electromagnetic broadcasts detectable by sensitive instruments. Type 2 civilizations would build Dyson spheres, massive structures radiating waste heat at infrared wavelengths to maintain operational temperatures. Astronomers have searched for such signatures using increasingly sensitive infrared surveys, finding candidates but no confirmed detections. Some objects exhibit anomalous properties, but none have been conclusively identified as artificial. Type 3 civilizations would reshape their home galaxies in unmistakable ways, creating asymmetrical structures, unusual stellar distributions, or anomalous energy patterns resulting from their engineering projects. Yet we observe no galaxies bearing hallmarks of Type 3 engineering. The universe appears devoid of obvious advanced civilization signatures, or perhaps we simply do not yet know how to recognize them. Zoo hypothesis implications suggest that advanced civilizations might deliberately conceal themselves from younger species. Perhaps Type 3 or Type 5 entities have established protected zones where younger civilizations develop uncontaminated by external influence. They might enforce strict non-interference policies, observing developing worlds like animals in nature preserves. We might inhabit such a protected zone ourselves, with advanced civilizations monitoring but never interfering. The zoo hypothesis would explain why we see no obvious Kardashev signatures. The entire cosmos might be inhabited and engineered by Type 5 civilizations operating invisibly, preserved systems dedicated to studying nascent intelligence. Contact might be forbidden by ancient treaties between Type 5 entities, agreements enforcing mutual non-interference in each other's development zones. Simulation argument considerations suggest that advancement zones. If we inhabit a simulation created by Type 5 beings, those beings might be constrained by their own simulation's physics. They might be unable to introduce visible anomalies without breaking internal consistency. They might deliberately exclude signs of higher-level engineering to maintain simulation integrity. Conversely, they might seed subtle signatures detectable only to sufficiently advanced observers, essentially leaving cosmic Easter eggs for civilizations reaching appropriate development levels. The very universe might be designed to appear natural and unengineered, while actually representing the careful handiwork of entities operating from dimensions outside observable reality. Detection challenges inherent to higher civilization searches become apparent when considering the scale disparity. A Type 3 civilization might be to us as we are to insects. The vastness of their engineering projects, conducted on galactic scales and across millions of years, might escape notice entirely. We observe galactic structure at too limited resolution and across too short time frames to recognize artificial modification. We lack theoretical frameworks predicting what Type 3 engineering would look like. We might observe Type 5 artifacts without recognizing them as artificial at all, interpreting them as natural cosmic phenomena. Detection becomes almost impossible, not because evidence is absent, but because our detection methods are inadequate to the challenge. What to look for in searching for advanced civilizations requires expanding our conception of anomalies. Rather than seeking obvious megastructures, we should look for subtle patterns suggesting engineering. Galaxies with asymmetrical structure or unusual gravitational distributions might indicate manipulation. Stars arranged in improbable geometric patterns might suggest deliberate placement. Unusual concentration of computational substrates in specific cosmic regions might indicate concentrated civilization activity. Anomalous particle streams or energy flows suggesting manipulation of space-time might reveal Type 2 or Type 3 engineering. Gravitational waves or temporal distortions indicating time manipulation technology might signal Type V activity. Statistical anomalies in the distribution of stellar remnants, planetary systems, or cosmic structures might betray civilization presence. The universe might be full of signs if we knew where and how to look. Megastructure searches have already begun through systematic surveys of the infrared sky. Astronomers searching for Dyson spheres examine stars for evidence of energy harvesting. They look for stars whose radiation output in infrared exceeds what natural stellar cooling would produce. Stars glowing brighter in the infrared than their visible light output would suggest. They search for thermodynamic signatures suggesting energy capture and civilization activity. Several candidate stars have been identified, including the famous KIC 8462852, whose light curves show unusual dimming patterns, potentially consistent with orbiting structures. The dimming occurs in patterns too irregular for natural explanations, suggesting either massive orbiting constructions or as yet unknown astrophysical phenomena. Ongoing surveys through infrared observatories continue expanding the search, examining tens of millions of stars for signs of energy harvesting infrastructure. Increasingly powerful telescopes examine distant galaxies for signs of Dyson spheres around their central stars. While no confirmed detections have yet been made, the search methodology becomes increasingly sophisticated and sensitive, and the possibility of discovery grows with each passing year. Waste heat signatures represent one of the most promising detection methods for advanced civilizations. Any technology converting stellar energy requires rejecting waste heat. A perfectly efficient Dyson sphere would still radiate waste heat at infrared wavelengths. A Type 2 civilization would create an unmistakable thermal signature, concentrating far more infrared radiation than natural processes would produce. By examining the infrared sky for anomalously bright regions or regions with unusual spectral characteristics, astronomers hope to identify candidate Dyson spheres. The James Webb Space Telescope and other advanced instruments offer unprecedented infrared sensitivity, potentially capable of detecting civilizations even if they attempted camouflage. The heat cannot be hidden indefinitely across galactic distances without technology approaching Type 3 capability. Unnatural cosmic patterns might reveal Type 5 engineering if civilization reaches sufficient advancement to recognize them. Perhaps the universe's fundamental constants contain messages encoded by predecessor civilizations. Perhaps cosmic structure shows mathematical patterns indicating deliberate design. Perhaps the distribution of galaxies across cosmic distances follows precise geometric arrangements rather than random clustering. Perhaps the universe's expansion rate itself shows evidence of manipulation. Perhaps quantum vacuum properties contain hidden information placed by advanced entities. Perhaps the apparent universe is structured like a simulated reality with fractal self-similarity or computational artifacts detectable to sufficiently advanced observers. The universe might not merely contain evidence of engineering, but might be itself the product of Type 5 design, with every feature carefully orchestrated. SETI implications of Type 5 civilization possibilities suggest that traditional searches for radio signals might be entirely misguided. A Type 5 civilization might employ communication methods beyond radio, using faster-than-light channels, dimensional bridges, or time manipulation techniques that circumvent light-speed delays. They might not broadcast signals, preferring secure point-to-point communication protected by encryption schemes undecipherable to younger species. They might not use electromagnetic radiation at all, relying instead on gravitational waves, exotic particle streams, or direct manipulation of space-time geometry that leaves no EM signature. They might communicate through means so alien that human technology would not recognize the signals as communication at all, interpreting them as natural phenomena rather than artificial messages. SETI's assumption that advanced civilizations would use radio might represent a fundamental misunderstanding rooted in human technological experience. The search might be listening for the wrong signals entirely, while missing unmistakable evidence of Type 5 activity occurring in different domains, perhaps imprinted in the quantum vacuum or encoded in the fundamental structure of space-time itself. Humanity's place in cosmic scale becomes apparent when considering Kardashev levels. We occupy approximately Type 0.73, measuring our civilization's energy use relative to planetary availability. We remain effectively helpless against cosmic events. A stray asteroid measured in kilometers across could extinction-level catastrophe our civilization. A nearby supernova explosion could sterilize our world despite its distance. We cannot meaningfully affect galactic-scale phenomena or even solar system-scale engineering. We cannot resist if an advanced civilization chose to colonize our world or redirect asteroids against us. We are not civilization actors, but cosmic passive observers, fundamentally dependent on conditions of our local environment, constrained by physics we cannot escape. Yet we possess something invaluable: potential. Given billions of years and continued technological progress without self-destruction, humanity could advance from Type 0.73 to Type 1, controlling all planetary energy. Then perhaps Type 2, harnessing stellar power. Then beyond. Our distant descendants, transformed by technology and evolution across millions of years, might become Type 2 or Type 3 entities. We are not yet powerful, but contain within ourselves the potential for cosmic dominance and survival across geological epochs. Humanity's potential future extends into almost unimaginable timeframes. If our civilization survives the next few thousand years without self-destruction, we might achieve Type 1 status. With another 100,000 years, Type 2 seems conceivable. Type 3 might be achievable in a few million years. Beyond that, the timeline stretches across cosmic epochs of scale, almost impossible to fathom, but it remains theoretically possible. Our descendants, transformed through technological advancement and evolution beyond our current conception, might eventually approach Type 5 capability. They might participate in multiverse engineering. They might become participants in cosmic civilizations spanning countless universes. Or we might remain forever at our current modest level, transcended by civilizations that started elsewhere in the cosmos. Ethical considerations of cosmic power become increasingly important as we contemplate advanced civilization capabilities. A Type 3 civilization possessing the power to manipulate galaxies faces profound questions about how that power should be used. Should they engineer universes according to their values or respect the natural development of younger civilizations? Should they expand infinitely or limit themselves to sustainable regions? Should they share their knowledge with younger species or enforce quarantine? Should they attempt to maximize happiness, consciousness, computation, energy extraction, or some other goal? These questions have no obvious answers. Different Type 3 civilizations might adopt radically different philosophies, leading to cooperation or conflict. The universe might be divided into territories controlled by civilizations with fundamentally incompatible values. Wars between Type 3 entities might occur at scales and with consequences difficult to comprehend. The outcomes would reshape galactic structure. The responsibility accompanying advancement seems inversely proportional to cosmic visibility. The most advanced civilizations might also be the most careful, constrained by ethics and wisdom acquired through billions of years of development. and countless historical lessons learned from civilizations that wielded power unwisely. They might view the power to reshape universes as terrifying rather than glorious, understanding that with such power comes near infinite potential for catastrophe and irreversible mistakes. They might enforce strict limitations on their own technological capability, preserving zones of wilderness where natural evolution occurs uncontaminated by engineering. They might invest enormous resources in preventing the emergence of younger civilizations that could threaten established order. They might secretly work to prevent other civilizations from advancing too rapidly through careful intervention designed to slow dangerous developments. The greatest powers in the cosmos might be the ones most restrained in their exercise of power, preserving universal stability through careful oversight and invisible governance that younger species never perceive. The universe might be peaceful, not because evil is absent, but because advanced civilizations have learned that unlimited power exercised without restraint leads to outcomes tragic for all participants. When viewed from this perspective, the Fermi paradox's silence becomes not terrifying, but reassuring. We have not been invaded or enslaved because advanced civilizations have determined that conquest violates principles they hold dear. We remain unmolested, not from our strength, but from their mercy and self-imposed restraint. The universe might be safer than we suppose, protected by entities whose power so far exceeds ours that our welfare barely registers as a consideration, yet whose ethics prevent them from harming us. In darkness and silence, the cosmos might teem with benevolent civilizations watching over younger worlds, guiding evolution toward flourishing without direct interference, preserving what they find precious in the natural development of life and consciousness across countless worlds and dimensions. The greatest civilizations might measure their achievement not by the energy they command or the territories they control, but by the wisdom to use their power sparingly, the self-restraint to allow other beings their own journey toward enlightenment and transcendence, and the commitment to preserve the multiverse's infinite diversity as one of the universe's greatest treasures. In this view of the cosmos, silence is not absence, but the sound of an infinite garden, tended by gardeners who have learned that the greatest act of power is knowing when not to exercise it.